Hello friends and welcome to my course on malware analysis and reverse engineering. I, Abhinav Singh, will be your instructor for this course and I'll be taking you to the exciting journey of playing with malwares. This course will teach you the most sought after skill of today's cybersecurity market to make you ready to jumpstart your career in the field of malware analysis and reverse engineering. A quick introduction about this course. This course covers a wide variety of topics ranging from analyzing malicious file formats, PDFs, PowerPoint presentations, etc., all the way to reverse engineering the actual binaries that constitutes the payloads. The course will follow a logical structure where we will analyze attack patterns at 5 different steps: weaponize, deliver, exploit, persist, and exfiltrate. We will deep dive into all these steps to uncover traits of threats in the form of spearphishing, drive-by downloads, etc. Who is this course for? Well, I have designed this course keeping most cybersecurity professionals in my mind. Whether you work as an incident responder, threat analyst, or a malware researcher, this course can be a good fit for you. This course is also well suited for beginners who want to jumpstart their career into cybersecurity and malware research. This course is going to be highly interactive, involving exercises, quizzes, and projects to keep your learning curve growing. As an instructor, I will always be available to help you with your queries and doubts, and together we can learn a lot from each other's experience. So if you have made up your mind, go ahead and register for the course and we can hunt some malware together. See you in the classes.
Hello friends, welcome to my course on malware analysis and reverse engineering. In this video, I am going to give you a detailed explanation about the course overview. Many of you might have seen a quick introduction about this course where I have explained about the overview, but in this video, I want to give you slightly more details about the course and how it's going to proceed further. Before we move on, I quickly want to introduce myself to the students. So I'm a security enthusiast and I have been working with the security industry for quite some time now. I enjoy spending time on stuff that are related with information security. I have also been a speaker at eminent conferences like Black Hat and RSA. The reason why I love talking at these conferences is because it gives me a chance to meet with like-minded people and also kind of create some ears for what you want to talk about. I've also authored a book titled Metasploit Penetration Testing Cookbook. The book has been released in 3 editions now and it's available on all major bookstores online. I'm also the author of Instant Wireshark. Both these books have been published by Packet Publishing House UK. You can also follow me on LinkedIn, Twitter, or GitHub. The links have been provided here. Now let us proceed to the course flow overview. So this is the same diagram which I used in the introduction video, and the reason why I want you to talk a bit more about it is because I want you to understand why I'm following this methodology. So when an attack happens, it basically has certain predefined steps which it takes or which the attacker takes in order to compromise the hosts. So what the attacker first does is that it creates a weaponization level where it targets the victim, plans the attack, starts doing the enumeration on different services. For example, what servers the host is running, what version of HTTP server is there, what version of SQL database is running, and stuff like that. Once that information is collected by the attacker, the next step is to deliver the attack. Now, the delivery of attack can take place in multiple ways. For example, it can be done through spearphishing or spam emails, where the attacker can embed malicious attachments and it can send that email to the particular user whose information was collected in the weaponization phase. Other delivery phases can include exploit kits or PUAs, etc. We will go into details of each of these delivery phases in the later videos. So once the delivery has been done, the next step is to exploit the machine. The reason why the attacker wants to exploit the machine is that a lot of times, once you get inside the system, you might not have the right privileges to do advanced activities like taking screenshots or probably installing new malwares on the system and things like that. That's where exploitation comes handy. Once the exploitation is done, the user can basically escalate its privilege to get more permissions onto the system which he or she has compromised. Once the exploitation phase is done, the next action that the attackers want to take is to create a persistence onto the system. A lot of times, the systems might reboot or you might shut it down and restart it later on. So, how do the attackers ensure that they have a persistence onto the system that they have compromised? This is done by different steps. For example, they can create registry entries for startups. So every time the machine boots up, the malware automatically starts onto the system. They can set up cron jobs. They can set up different WMI scripts and stuff like that. We'll go into a lot more details about each of these stuffs when we will be analyzing malwares, because these are very critical in understanding how malwares infect the system and how they kind of create a foothold into the network and systems that they have compromised. So once the persistence has been done and the malware has maintained a foothold into the system and the network, the next step is to exfiltrate the data. The data exfiltration would happen by sending stolen data to its command and control server. There are different ways by which they do it, and we will be seeing that in much more details in the later videos. So this was a quick overview of the entire workflow that an attacker takes, and I have designed this course based on this workflow itself so that we basically not directly jump into understanding malwares. We first understand the attacker's mindset, how they craft their attacks, and then only we can create effective defense methodologies around each of these steps. Well, all these steps have been borrowed from a very popular cyber kill chain model. This kill chain model basically layers down the different steps at which an attack takes place. There are basically 7 different steps in the cyber kill chain, but I have narrowed it down to 5 major steps. And this is why I just wanted to quickly give you an idea about the cyber kill chain. We'll be going into the details of these steps in the next video as well, but I just wanted to let you know that the concept is basically picked up from the cyber kill chain. We'll be mapping all the attacks at these steps and we'll be applying the analysis strategies based on how the activities are performed. The entire course is divided into sections. For example, the first section is course introduction and overview of the cyber kill chain. The section will contain multiple lecture videos, and along with those lecture videos, there will be different assignments associated with them. So that's the logical flow, and that's how Udemy has designed the course. And this is how we are going to design the entire course around these sections and assignments. So that's it for this video. Thanks a lot. Hello friends, welcome back to the course. Let us discuss the next important topic here, and that's about hardware requirements. So what will be the hardware requirements for completing this course? The requirements are pretty basic, and almost all modern day laptops or PCs will have this configuration, but it is ideal to have a CPU of 2 to 3 gigahertz of processing power and RAM of 8 to 16 GB. The RAM will be critical here because we have to run a bunch of virtual machines. That will be like a safe environment where we will be executing and analyzing the malware files. We would also require at least 100 GB of storage space. That's the ideal scenario, but if you have less than that, for example, let's say 60 to 80 GB of space, then that should also work out. But it would be best to have at least 100 GB of storage space free to perform all the operations of this course. Coming to the software requirements, the requirements again here are pretty basic, And as we proceed in the course, we'll be talking more about what kinds of tools and softwares would be required to do some specific analysis goals. So, starting with the operating system, so it would be good to have either a Windows or a Unix based machine, either Mac or Linux, that should be sufficient to host your virtual environment. You should have Windows 10 or Windows 7 as a guest OS or as a virtual OS, because most of the malware analysis tools are designed for Windows environment. So it would be ideal to have a virtual image of either Windows 10 or Windows 7 where we can do the analysis of the file formats. We would also need virtualization software like VMware or VirtualBox. Obviously, these softwares will help us launch the guest OS, which is a Windows environment, and we will be setting up our entire analysis lab in this guest environment. The next video will basically talk about how we are going to set up the entire environment here. There will be some additional tools that will be required as well during the course. Some of them have been listed here like IDA Pro, Wireshark, P Studio, CFF Explorer, Text Editor, etc. This is not the complete list. There will be few more tools that would be required as well, and there are a bunch of ways how we can go through it. We can either install all these tools in a single go when we are setting up our malware lab, or we can set up a basic environment where we have the Windows guest OS running, and we can start using tools one by one as we proceed with the different steps of analysis. So both options are there. We'll see how we want to take it forward. Then we would also need malware samples that can be downloaded from VirusTotal and other open sources. Uh, Obviously, because we are going to do analysis of malware files and malicious files, it's ideal to have a separated lab kind of environment where we can have these files downloaded, where we can start analyzing them. And because these are actual malware samples, actual infected files, it would be ideal to have them saved in an environment where it cannot really infect the your host operating system. So we would need sources from where we can download all these malware samples. You can get the information either from VirusTotal or probably some other open sources. There are a lot of different sources and very good sources from where we can collect malware samples, and we'll be talking about them in great details later on. I'll also try and provide you these malware samples by hosting them on my personal cloud account if it doesn't violate the policies of the cloud services. And probably from there as well, you can download those samples and analyze the courses. So that's all about this video, and in the next video, probably we'll go ahead and discuss about how we can set up our malware lab. Thanks a lot, guys. Hello friends, welcome back to the course. In this video, we are going to talk about setting up your own malware testing lab. So what are we really going to do here? We are going to set up a separate virtual environment. So a lot of times we only have one system at our disposal. So having a separate virtual environment kind of creates two different environments within the same box. You have your own main operating system and you have a separate virtual environment where you can do your malware analysis work. A separate guest OS to manage all the tools and samples at one place. So again, once you have a separate virtual environment ready, you can have all your tools, all your malware samples and everything located centrally, and you don't really have to search for them here and there. And if you have antivirus programs running on your main operating system, it's not really going to interfere with your malware lab. The traffic that originates from your malware lab might get intercepted by the antivirus running on your host operating system, but apart from that, the files and other softwares and tools that are there in your virtual machine will not be impacted by any antivirus that is running on your host operating system. Any infection that happens in your virtual environment can easily be reverted back to a clean state. So what I mean by that is, let's say you have set up your virtual machine, you have downloaded all the tools, then before you begin any analysis, the first thing to do is take a snapshot of that virtual image so that you have a clean state where you can always revert back just in case if your machine gets infected. And that is definitely going to happen when we are going to analyze malwares by dynamically executing them in different debuggers. So what would be the lab requirements here? So you'll have to download a Windows 7 or a Windows 10 ISO image. There are a bunch of resources how you can do it. You can even get the images downloaded directly from Microsoft's official website. Both these operating systems would be ideal, but if you want to use Windows XP, I would highly discourage that because that is the support for that operating system has now been stopped by Microsoft and it's very old. So it will be ideal to start with either Windows 7 or a Windows 10 ISO or image. You can download it from internet or from Microsoft's website and you can begin setting up your environment. You would also need VMware, which is a licensed tool that helps you set up your virtualization environment. If you don't want to use VMware, you can also use VirtualBox, which is free of cost and it can help you in using your Windows 7 downloaded images in converting it into an actual virtual environment for you. So once you have the image and your virtualization software ready, you can load the image, run the ISOs to set up your environment. I want to leave this as an exercise for you, and there are a lot of very good resources that are available online that you can read and see how you can set up a malware lab using your virtual environments. I would recommend reading a blog written by Lanny Zelster, which talks about how we can set up the malware lab in just 5 simple steps. So go ahead, read these resources and try and setting up your lab. This is not going to be very complicated. It's a very simple step. All you have to do is download the image, download the virtualization software, load those in the image, and you are all set to go. So go ahead and perform all these steps. And once you are ready, let's get to the next video now. Hello everyone, welcome back to another video. In this session, we are going to talk about setting up the tools in your malware testing lab. I'm assuming that you were successful with setting up your virtual environment either using a Windows 7 or a Windows 10 machine. In my case, I am using Windows 7 machine as my virtual environment. The next step would be to setting up the malware tools in your testing lab. So how do we go ahead and do it? Well, we can either do it one by one, like let's say in the later videos, if we start working with PDF files, then we can download the specific tools that might be required to analyze PDF files. The other way is to use the Flare VM, which is a tool provided by FireEye. This basically automatically downloads a bunch of security tools onto your virtual machine. It's not a very exhaustive list, but it still contains a lot of important tools that you can use while we are analyzing malicious malwares or malicious files, etc. So how do we go ahead and do that? Here is my virtual Windows 7 environment. You can basically go to github.com/FireEye/FlareVM and you can go to the top. You can click on clone or download and you can click on download zip file. This will download the zip file on your machine. You can then extract its components and you'll see that it contains a bunch of PowerShell scripts that you can use to install all the different tools on your machine. If you scroll down, you'll also see that there is an installation instruction that has been mentioned. It's pretty easy to install. You don't have to do anything. You just have to run these two commands. And to run them, you need PowerShell on your Windows environment. So let's quickly launch PowerShell. It's better to just run it as an admin so that if there are any higher privileges required, then it should not be an issue for our tool. So we go to the directory where all the files are located, and all we do is we first pass set execution policy as unrestricted. We give it yes, and once that is done, we run the PowerShell script to begin the installation. So once the installation starts, it will take a couple of minutes to have everything set up on your machine. But once the installation is done, you will basically see a folder called Flare created on your desktop, and it will have a bunch of analysis tools in your environment. There are very useful tools. You can see there are a few tools for PDF file analysis, there are a few for Office file analysis, there are hex editors, there are disassemblers, there are debuggers. All these tools are really handy, and we are definitely going to need them in some point or the other in later stages of the video. And if there is something which is not present here, we can obviously go ahead and download them and work as we need. So this was a quick video to tell you about how you can set up all the different analysis tools in your environment. That's all for today. Thanks. Hello everyone. Welcome to another video of Expert Malware Analysis and Reverse Engineering course. And in this video, we are briefly going to talk about REMnux. So what exactly is REMnux? REMnux is a Linux toolkit for reverse engineering and analyzing malwares. In the previous couple of videos, we worked extensively on setting up a virtual environment where we downloaded images of Windows 7 and Windows 10 to set up our virtualization environment. We downloaded virtualization tools to get ourselves up and running. We also spent time on downloading a lot of different tools using the Flare VM so that we have our entire setup ready. REMnux provides us a single Linux distro which comes pre-compiled as a OVA file or as a virtual image that you can quickly boot into your virtualization software, and you don't have to really worry about installing tools or getting images and stuff like that. This is where REMnux is very useful. REMnux is basically developed by SANS, which is a very popular certification company that runs a lot of technical certification programs. So some of the good features about this Linux distro is that it comes with a lot of tools that can be helpful during malware analysis. One of the best features that I like about REMnux is that it comes with containers as well. So they are basically Docker images for malware analysis tools where you can quickly load up the Docker image, you can do the analysis, and once you are done, you basically kill that Docker image and the infection just stays out. In the later stages, once we are done with analyzing files manually on virtual machines, we'll be looking into analyzing Docker containers as well. So that was all about REMnux. It was just a quick brief. I would highly encourage you all to just go ahead, go to remnux.org. You can download the distro from there and you can just load it in your virtualization software and you can start playing around with it. Here is a running instance on my machine. Once you are set up, once you boot it, you'll see something similar here. You can go to start, you can go to other, and from there you can see the bunch of tools that are there. This is not really the exhaustive list. There are a lot of other tools as well which are present inside REMnux. One of the most useful things is the REMnux cheat sheet. This is very handy thing. It contains a lot of tools that we can use in different stages of malware analysis. If you look here, they have mentioned all the tools under different headings. For example, how do we examine browser malwares? We can use SpiderMonkey, we can use Rhino debuggers, we can use Firebug. For examining memory using volatility, they have listed all the important commands that are related with volatility and stuff like that. This cheat sheet is really handy, and we can anyways refer back to it anytime when we want to, let's say, pick up a new tool to understand a file or really extract the deeper components of a file to uncover its malicious traits. So that was all about REMnux. Just go ahead, download it and play with it and let me know how was your experience. Thanks a lot. Welcome everyone to another video of Expert Malware Analysis and Reverse Engineering course. And in this video, we are going to give a detailed introduction to the cyber kill chain model. The term kill chain was originally used as a military concept related to the structure of an attack consisting of the target identification, force dispatch to the target, decision and order to attack the target, and finally destruction of the target. Also, the same idea is used in terms of breaking the opponent's kill chain in order to build a defensive strategy against it. Lockheed Martin adopted the same kill chain model into cybersecurity, and we call it as the cyber kill chain model. So what exactly this model consists of? So it consists of 7 different stages of intrusion, which is called the intrusion kill chain. It consists of reconnaissance, weaponization, delivery, exploitation, installation, command and control, and action on objectives. We have briefly seen some details about the cyber kill chain in our previous introduction videos as well. Here we'll slightly go into much more details of this step, and we'll try and understand how this is critical to any cybersecurity professional, as it is very useful in day-to-day analysis of threats and attacks. That was the intrusion part of the kill chain. If you look at the lower part of this diagram, you'll see that there are the defeating steps as well, which are the detect, deny, disrupt, degrade, deceive, and destroy. So if you are an attacker, you are basically following the intrusion kill chain, the top 7 steps, and if you are a defender, you are basically following the lower 7 steps, or you are basically using the 7 Ds to kind of detect or disrupt any ongoing attack or campaign. So let us go into a much more detailed explanation of all these steps one by one. So we start with reconnaissance and weaponization stages. So in reconnaissance, the attacker basically does an extensive research on the target. They try and identify the servers, the machines, the version of softwares, the employees, their email IDs, their contacts, and things like that. This is basically the information gathering stage where the attacker collects as much information as possible. In the weaponization stage, the attacker uses the collected information from reconnaissance as its next step towards building the attack. The attacker basically starts thinking about the right mode for victimizing the target. Then comes the delivery phase. So once the attacker has identified his weaponization stage, the next attack vector would be to deliver the weaponized item to the target. For example, spam emails. Let's say the attacker in the weaponization phase was able to figure out the email ID of few HRs working in an organization. The attacker then decides to create a weaponized malicious email and deliver it to all those HR personals. That particular email would contain an attachment that would have an exploit inside it. That's where the exploitation phase comes into action. So in the exploitation phase, compromising the target in order to get unauthorized access and an elevated privilege of the system that is compromised. Once the exploitation is done, the next phase is the installation of the malware. So the malware will now sit onto the system in order to start performing the command and control. And the command and control is basically the exfiltration of data, stealing of critical information from the infected machine, from the infected network, all the way out to its own controlled server. So this is how the attack is layered for all the 7 steps of the cyber kill chain. Similarly, we have the proactive defense and mitigation steps as well. So in the kill chain, if you look at the first 3.5 steps, if we just divide the exploitation into, let's say, 2 halves, then the first 3.5 steps basically tells you how you can proactively detect and mitigate any threat. That's where most of the security tools work upon. For example, you can have spam filters, you can have antiviruses to basically proactively detect and mitigate the threats that happened in the environment. For the later 3.5 steps, you basically do a containment and incident response. This means that the attack has already happened, the network is already infected. Now you try and contain it, and you try to understand how that incident happened, what was the reason for that infection, where else did that infection flow from the particular machine where it happened. So here is a brief diagram of the example of a spam attack mapped on the cyber kill chain. If you see a spam email arrives onto the victim machine that contains a zip file, the zip file inside contains a document file. The doc file can contain multiple different exploits based on which of them work on the compromise. So once the exploitation happens, the malware gets installed onto the system, and after installation, the malware begins communicating with its command and control server. So this is how the entire attack is mapped with the cyber kill chain model. This is going to be very helpful for us throughout this course because our analysis is also going to start in the same way. We'll first look at a spam email, then we'll go ahead, we'll look into its attached document. Once we analyze the document, we are going to extract its features. It might contain exploits or it may directly try and install a malware. Then we are going to understand those exploits, we are going to understand those malwares, and then we are going to see how that malware sits into the system, how it elevates its privilege, and later on how it performs the command and control. So this is the overall structure, the overall course design, and this is how cyber kill chain basically maps the entire attack onto a single model. So that was a good introduction for cyber kill chain. There is a lot of information available on Google as well. I would highly encourage you all to just go ahead and read more about cyber kill chain and how different organizations are using it to build up their defense, to build up their proactive detection strategies around this model. That's all for this video. Thanks everyone. Hi everyone, welcome to another video of Expert Malware Analysis and Reverse Engineering course. And in this video, we are going to begin with analyzing the attack kill chain phases into much more details. So the first two phases of the cyber kill chain model are the reconnaissance and the weaponization phase. So this is pretty much the pre-attack phase where the attacker tries to gather information about the victim, and once the information has been gathered, they try and create a weaponization stage where they can infect or target their victims. So how to perform passive reconnaissance? So basically what I mean by passive reconnaissance is gathering information about your victim without making any direct communication with them. So this means that I'm not scanning their services, I'm not establishing any form of communication with them. I'm just using open source intelligence or open sources to gather information about my target. So information available online like Google search, Twitter, and LinkedIn can be one of these sources. Collecting information about public IP, web services, and other internet facing services. So a lot of times the companies have their public IPs, web services, etc. Available in the global repository. For example, domain dossier is one repository where you can just enter the IP address and you can get a lot of information about what services are hosted, what's the range of that IP. You can also get information about their email protection policies and things like that. The other passive reconnaissance activity can be whois and reverse lookup. So again, these two are very popular Unix tools which you can use to basically query your DNS server to get more information about a given service. Again, in this case, you are not making any direct connection with your target. You are just collecting information that is publicly available at various sources. Collecting target information like employee emails, contact numbers, work location, etc. Now, if you remember the example that we saw in the previous video where a spam email was delivered to the employee and that spam email contained a malicious attachment that had an exploit inside it. So before you can send that email, you need to figure out who do you want to send that email to. This is where passive recon comes into action. You basically try and gather information about the weak points. You try and gather information about users or employees of your target organization, and from there you use that information to build your next stage. Active reconnaissance is the second reconnaissance activity that the attacker can try and implement So this involves port scanning and fingerprinting. Now, port scanning is an activity where you pick up an IP address of your target and you scan for all open ports that are there for the given IP address. So what this gives you is information about what services are running on those ports, what version of services are those, etc. Now, this is a scanning technique where you're directly making a connection with your target. That's why it's called an active reconnaissance. So port scanning and fingerprinting can be performed using common tools like Nmap, Dig, NSLOOKUP, and Maltego. Then you can also run a bunch of dummy tests. For example, let's say we all know that if there is a company xyz.com, then there will be an alias email address as hr@xyz.com, or let's say corporate IT at xyz.com. So these are some common email aliases or email groups that should be present in almost all the organizations. It basically consists of all the users which are within the HR group or which are within the IT group. So you can basically run a bunch of dummy tests by sending some sample emails or by sending some dummy emails to those address and see whether they get delivered or not. If you don't get any failure notification back, it means that those email addresses actually exist, and in the next stage you can actually send your weaponized file. So once the reconnaissance phase has been done, the next step is building the weaponization file. Now, choosing the attack vector depends on the information that the attacker gathered in the reconnaissance phase. So in the reconnaissance phase, you might have gathered information like email addresses, IP addresses, or open ports, and what services are hosted on those open ports and things like that. So once you choose your particular attack vector, that's when you're going to decide how you're going to weaponize that. For example, again coming back to the email spam case, let's say you figured out a bunch of email IDs of HR professionals of your target organization. You can start crafting a malicious spam email and attaching a malicious file with name as resume. You can go online and you can see that the organization has posted bunch of openings online. For example, let's say a software developer, you can create an email and add an attachment that this is your resume for the software engineer role, and that's how you can basically craft your weaponization stage. So the weaponized file will also shape the delivery mechanism. So once your weaponization file has been created, you basically go ahead and deliver it to your particular target. So that was a quick introduction about reconnaissance and the weaponization phase. Later on, we will start looking into the delivery phase and we'll see how the spam emails basically reach into an organization and how we can further analyze them. That's it for this video. Thanks. Welcome back everyone to another video of expert malware analysis and reverse engineering. We will now proceed with the delivery and the exploitation phase. And from this phase, the real malware action begins. And that's how we are going to now proceed with much more of hands-on exercises rather than theoretical exercises. So before we move ahead, let us quickly go through the details of delivery and exploitation phase, and we'll again be using the example of a spearphishing email. So what is exactly spearphishing? So spearphishing is a technique that is used by attackers to basically launch a targeted attack against any given individual or against any given corporate. So if you remember the discussions from our previous videos, we talked about the reconnaissance and weaponization phase, and then we said that the attacker collects information about the host or about the target or about the organization, and based on the collected information, it crafts the weaponization stage. And once the weaponized file is created, it will use a delivery mechanism to kind of initiate the attack pattern. This is what is listed here in step number 1, 2, 3, and 4. So what is special about spearphishing and how is it different from phishing? Now this is an important difference to understand. A lot of times interviewers in cybersecurity positions, they ask you this question like, what is the difference between a phishing attack and a spear phishing attack? Well, a phishing attack is a very broad attack where the attackers send a malicious email to, let's say, thousands of email addresses. They don't really care about who gets infected, or they don't really target a specific individual or organization. Their goal is to target as many people as possible, and they send that email to a lot of targets. In spear phishing emails, they are more tailor-made towards a particular individual or towards a particular organization. Some of the common examples are the CEO scams that we see, where some of the particular employees of a company, especially the employees who are working in the finance department, are usually scammed by sending an email which looks like it came from the CEO of the company, and they would ask you to transfer some money from the official bank account to some other bank account. So that's more about spear phishing, where they specifically target individuals or organizations. So let us quickly talk about emails as a delivery vector. So in the delivery phase, once a recon and the weaponization file has been generated, the attackers can use email as a delivery vector. So it can be targeted phishing attack, where the attackers can specifically try and send the email to particular individuals inside the organization. For example, people who might have higher accesses within the organization, let's say system administrators. If you manage to compromise a system administrator's account, you can get a lot of privileges inside the network. It is specific to a group of people and organization. It's hard to detect as they are tailor-made to look genuine. So for a normal human, it might be difficult to really create differences between a legitimate email and a spear phishing email. Since spear phishing emails are pretty much targeted, they are very nicely crafted and they would very much look like a legitimate email. We will look at a bunch of examples starting from the next video. So that's the reason why spear phishing emails are also difficult to detect compared to normal phishing emails. In case of email as a delivery vector, victims are asked to download malicious attachments, click on embedded URLs, or reply with sensitive information. Now, what can be the steps to identify malicious emails? You should carefully assess the sender who sent you that email. Don't just go by the display name that comes in. Also look at the email address that was registered for that particular display name, because a lot of times the display name might be something that can be very familiar to you. For example, John or Peter, or some common name which you might be knowing that particular person. So it's always advised to carefully look at the sender details. Looking at the message body, now this is slightly on the technical tracks, how we look at the message headers to basically see where that email actually originated from. We'll be looking into much more details in the next video as to how we can analyze an email message body. Also carefully assess any embedded links and attachments that are there in the given email. This can help you in being much more vigilant and avoid from clicking on unsolicited links or opening any unsafe attachment in your corporate network. So that's all for the delivery phase. In the next video, we are going to give a much more detailed and technical view of how we can analyze a spear phishing email. So that's it for this video. Thanks for watching. Welcome everyone to another video of Expert Malware Analysis and Reverse Engineering course. In this video, we are going to analyze email headers, which is a part of our delivery phase. So to begin the analysis, let us head to our Windows VM, and here are a bunch of malicious email examples that I want to share with you all today. So the first one is a .msg format, and the next two are EML. They both are standard email formats. I'll be using Microsoft Outlook in order to view these three emails. To have Microsoft Outlook on your machine, you should have Microsoft Office package installed. You can find more details about it on Microsoft's website. If you don't want to use Microsoft, there are other options as well. For example, you can use open email clients like Thunderbird. So let us look at the first email here. So if I launch it in Outlook, this is what I see. I see that the email comes from account payable. It has been sent to this particular person, and the message says that please find enclosed statement of account and due balance as requested. So there is an attachment as well which says that current statement of account at XLS. So if you remember from our previous slide, we said that to analyze an email, the first thing that you should look at would be the sender and the sender's email address. So the sender here is account payable and the email address is registered with oneyahoo.com. So this definitely seems suspicious. It doesn't seem like something that is coming from your own accounts department. Plus it has a suspicious attachment as well, an XLS file. So Outlook has a pretty cool feature of previewing your proprietary Office formats like XLS or doc or PPT. So we can basically click on this attachment and we can look at a preview of the file. It's not really executing the file, but it's just loading it within the Outlook environment. So it seems like this is an Excel sheet. It has 3 sheets and it's basically saying that this document was created with an earlier version of Windows macro is required to view the document, and it asks you to enable your macros. Now this is a kind of technique that the attackers have been using to enable macros in your Office environment. We'll be understanding this a bit more in detail once we start analyzing these particular malicious files. Let us come back to our email again. So if you remember, we also talked about analyzing email headers. So in Outlook, you can get the email headers by simply clicking on this small down arrow here, which gives you all the message options. So once you click here, you will see the internet headers. You can just copy the entire thing, open it in a notepad, just paste it here. So here we can see the complete email header. Let us quickly parse through it and understand them. So the first line says that received from freeterm.com. So this is basically the recipient organization, and that's its particular email exchange server where the email was received. Then it has some details about timestamps, and if you go further down, you'll have more information about where that email got received. And there are some information about the hosting of that particular email. And you see that the email has been sent to this particular email address, and it has been sent from this user and email. That's the information about when the email was sent, and then there is the hash digest of the email. Scrolling down, you'll see some exchange information, which are pretty much the exchange headers that are appended by the company's email exchange service. So this is how we locate the email headers, and this is more like the raw information that that gets added to a given email when it bounces through multiple exchanges, or when it gets resolved into which location where it should get delivered to. Let us look at our second example here. So if you look at the second email, again it has been sent by someone named Maria. That's the email address, and there is an attachment called inquiry rfq.doc. So this time there is a doc file which is an attachment, and it's a pretty long email. There are a lot of things in this email where they're talking about some business dealings and all those things. So these are some of the ways that the attackers implement to create a very unique email so that it doesn't look like that it was just randomly sent. It tries to incorporate as much originality as much as possible. Let us look at the email headers here as well. So again, we have pretty much the similar information, where that email came from, whom it got delivered to. Then there are MIME version informations. Then there is the email digest. And if you come down, there are some interesting information in this case. If you see, there is a user agent which tells us about the particular email client that was used. Then there is an anti-abuse information as well. So if your exchange was able to detect that this email doesn't seem to be coming from where it claims, then it basically adds an anti-abuse header into the email. This basically keeps a track of any abusive email that the email client thinks got delivered into your network. So it says that the primary host name of the abused email is this, and the original domain from where this email has been sent is firstampumps.com. So this is the information that the email exchange service has appended to this email. If you come all the way to the bottom, it says that the sender did not meet the SPF rules. That's why this email was classified as spam. So it's important to understand what exactly SPF means here. So Sender Policy Framework is an email validation protocol that is designed to detect and block email spoofing by providing a mechanism to allow the mail exchanges to verify that the domain that sent the email address is basically allowed to use the IP address to send that particular emails. So what SPF does here is that it ensures that the domain from where the email came from is allowed to send emails using this particular IP address. If this validation fails, it means that the email is getting sent from an IP address which is not authorized to use the particular domain to send the email. This is what SPF checks for. And if that particular checks fail, then the email exchange gives it a spam indicator that this email might be suspicious. So Sender Policy Framework cross-validates that the domain from where this email has been sent is actually registered with the correct IP address from where the email came. If the match fails, the email client automatically says that the SPF check has failed, and this is why this email was deemed as suspicious. You can read a bit more about Sender Policy Framework and how it helps in categorizing whether an email is spam or not. I'll be adding an exercise on SPF into this video as well. So this is how we can understand and analyze spam emails by looking at the email headers. Now in the next few videos, we are going to give a deeper look into the malicious attachments that comes with these spam emails. So that's it for this video. Thanks a lot for watching. Welcome everyone to another video of malware analysis and reverse engineering course. So in the previous video, we understood how we can analyze email headers to understand whether a given email is spam or not. We also noticed that those emails consisted of malicious attachments as well. So starting from this video, we are going to dive deeper into understanding those attached file formats, and we'll try and see how we can uncover the malicious characteristics of those file attachments. We want to start with understanding Microsoft Office file formats because it is one of the most popular file formats that is used by everyone. By Microsoft Office file formats, I'm referring to common files like Microsoft Word, Microsoft PowerPoint, Microsoft Excel. These are one of the most common everyday tools that are used in enterprises. So Microsoft Office format has two different file formats. One is the OLE compound file and the second one is the OpenOffice XML or simply OpenXML format. So first let us look into the OLE compound file. So OLE stands for Object Linking and Embedding. In this file format, a document would consist of different objects which are linked with each other, thus forming a complete container of the document. It is a hierarchical collection of stream and storage objects. It consists of a root storage object with optional storage objects and stream objects in a nested hierarchy. It supports older versions ranging from Microsoft Windows 97 to 2003. The fourth point lists a bunch of hexadecimal characters. I want to leave this as an exercise for you to go and figure out what exactly those hex characters mean. You can definitely find the answer to this question in the discussion section as well, but I would highly encourage that you first go and figure out what exactly these hex characters mean. So here is a pictorial representation of the OLE compound file formats, and this will make things a lot more clearer to you. So as we saw in the previous slide, there is a root storage, and the root storage consists of stream and storage in a hierarchy. Now the storage can further be subclassified into either storage or stream objects. Now a stream is basically the collection of data that is present inside the document, and the storage can further contain either stream or storage objects. So if you look at the diagram on the right hand side, there will be a root storage, and within that root storage there is another storage called macro. Within that macro there is another storage called VBA, and there are bunch of streams like one table, comp object, summary information, Word document. So if you create a Word file, there will be a root storage at the top, and if that Word file contains macros, there will be a storage called macros. Now whatever text that you type inside that Word document gets recorded into the stream that is called Word document, the one here at the last. So these streams basically contains the data about the particular document. Now if your document also contains macros, there will be a storage folder called macros. Within that there will be another storage folder called VBA, and within that VBA there will be bunch of streams that will contain the data. And by the data, what I mean is that they will contain the actual VBA codes. So this was an overview of the OLE compound file format. Moving on to Office OpenXML format. This is for the newer versions of Microsoft Office ranging from 2007 and onwards. It's much more simpler than the OLE compound file because it's simply a zipped file format where you basically collect bunch of linked files and you kind of zip them and create a top level file format for the particular document. It represents document in the form of markups, which is definitely the property of XML. So how do you analyze a docx file? It's very simple. Once you have a docx file, all you can do is just remove the docx extension from behind and replace it with zip. And you can just right click and unzip, and it will give you the entire content that is there inside the docx file. So I want to specify that docx is the extension of the newer versions of Microsoft Office, like docx, xlsx, pptx. These are the newer versions of Microsoft Office. The older versions, the OLE compound file versions, they have file extensions as doc, ppt, xls, etc. So coming back to the docx file package, let's say you right clicked and unzipped the entire package, you will see a bunch of different file names. You'll have rels, docprops, word. Inside word you will again have relations. So the relation is nothing but a lookup for each item that is referenced inside the document. You'll have another file called document.xml. This is basically the text of the document where the entire text that is there within the document file will be present. Then you have header and footer that will contain the information of the header and footer that you create inside your document. You have styles, media, themes, charts, and so on. So this is how the newer docx file formats are created by Microsoft Office. So that was all about the two different file formats that Microsoft Office supports. Starting from next videos, we'll start doing a deep dive into actual files to understand how we can uncover the malicious traits out of them. That's all for this video. If you have any questions or if you want to understand more, please do write in the discussion section and we can discuss more about these file formats. Thanks a lot for watching. Bye-bye. Hello everyone, welcome back to another video of expert malware analysis and reverse engineering. Starting from this video, we'll start analyzing a bunch of malicious document files. In the previous video, we looked at some spam emails and we understood how those spam emails can be identified. In the next step, we'll try and analyze the malicious attachments that comes with those spam emails. So to begin with, we understood the file structure of document files, and starting from this video, we'll start dissecting them into much more details as to understand how we can uncover malicious macros or malicious scripts that are hidden within those document files. So this snapshot is basically the hex representation of a doc file. So you can basically use any hex editor to open a document file to view the content of the file in hexadecimal format. Now, if you look at the first few characters, this basically is something that we discussed in the previous video where I said that I'll leave this as an exercise for you all to figure out. So basically the first few bytes represents the magic number of any given file format. And in the doc file, the magic number is D0CF11E0A1B1 1A and E1. So this was the exercise which I quickly wanted to point out. You can use any popular hex editor. There are a bunch of very good free hex editors as well. My personal favorite is 010 editor. It's pretty powerful and it has a bunch of file analysis templates as well, which makes it very easy to separate different sections of the file by just marking the locations in the hexadecimal formats. Okay, so what are the tools for analyzing malicious documents? We'll be covering two of them. One is Oledump and the other one is Oletools. Let's quickly look into Oledump. So it's an OLE file parsing tool that is developed by Deirdre Stevens. It allows you to analyze data streams and embedded macros. It supports docs, PPTs, and XLS. You can get more details on Deirdre Stevens' website. That is, the link has been mentioned here. So setting up Oledump is pretty straightforward. You can download the zip from the official website and you can just run the Python file. You need to have Python already present on your machine. You would also require a dependency called OLE file IO, which is a Python library that helps in parsing of OLE compound file formats. The tool is cross-platform, hence we can use it both on Windows as well as Linux VMs as well. For example, we can use it in REMnux as well, which we discussed in the first section where we talked about REMnux distro, which is a single distro for malware analysis. The good thing is that Oledump gets installed with Flare as well, and we talked about Flare as well when we were setting up our malware lab. So if you have followed those steps, you should already have the proper environment set up and ready for using Oledump. If not, you can obviously follow these steps to have Oledump set up on your virtual machine. Okay, so let's jump to our virtual machine. Here is the website from where you can download Oledump. There is a quick tutorial as well. It's very helpful. You can quickly read through it to get an idea of how Oledump works. To begin using it, let's come to our Flare tools folder. Here you'll see a folder called Office. If you go inside it, you'll see that there is already Oledump present here. There are a bunch of different OLE tools here. We'll predominantly be using oledump.py. My analysis files are present in a folder called course files. Here I have payment.docs and statement.docs. These are the two files that we'll be analyzing now. Welcome back, everyone. So let us start analyzing the malicious document file using Oledump, and I'll be sharing all these analysis files through a cloud link, probably through Dropbox. I'll password encrypt those files and I'll upload it there, and I'll share the links in the description sections so you all can download that files and you can follow these videos by analyzing the same file so that it makes things much more clearer to you. So let us quickly go ahead and launch PowerShell. Make sure to run it as administrator. So we are in the Flare Office directory now. That's where we can start using the program, and our file is present here. So okay, so to start using Oledump, you have to use Python to run the Oledump Python file, which is, let's first move to the directory. Now Python oledump.py. So before we analyze any file, let's just quickly run the help command and see what all parameters are there. So we have dump, we have ASCII dump, we have strings, we have VBA decompress, we have raw, and bunch of other things. You can explore all of these one by one. So in order to analyze given doc file, all you have to do is you have to run oledump.py and you have to pass your office file to this course files, and it's called payment.doc. So let's run this file. So here is the output of Oledump. So here you can see that it has separated all the objects one by one along with its size. It has listed the comp object, the summary information, the table information. Then it has also listed that there are macro projects inside this particular doc file. Now the one that would be interesting is object number 7, where it has marked capital M. It means that this document particularly contains macro scripts inside it. Now in order to view the macro script, we have to again run the same command, oledump.py, and this time we'll pass the -x parameter along with the object number, which is 7. So here it will list the hex value of the object. Now in order to view a more readable format, we can basically pass the -d command, which just dumps the entire result. Now here you'll see that there are a lot of unwanted characters as well. These are basically the characters which didn't really get translated into direct readable ASCII characters, but if it still makes a lot of sense. If you look at the code, you'll see that it's basically trying to launch command.exe and it's trying to do something with PowerShell. Now in order to get rid of all these unwanted characters, we can basically do a VBA decompress and it will create a pretty nice script for us. So here the output that we are seeing now is the actual VBA script that is embedded inside the particular document file. Now it makes it much more easy to read and understand here. So if you see, it has defined a function called document open, which means that this function will get executed as soon as the document is launched. What it does is that it launches shell command where it passes cmd.exe, basically the command prompt.exe, and from there it tries to launch PowerShell. Notice the way how PowerShell has been mixed and matched with both upper and lower case characters. This is done to usually avoid static signature based techniques where you have either PowerShell all in lower or in upper case characters. So all those techniques can be evaded using these kinds of mixing and matching. After that, it's basically trying to initiate a web client and it's trying to download a file from this particular location. You can see the entire file location here, and it's an exe file. It means it's an executable. It's very highly likely that this is the actual malware payload that will get downloaded from this particular office file. It gets written into temp app data and it gets written with the name of play.a.exe. So once the file gets downloaded, the next command that gets executed is start this particular file. Once the file is executed, you just exit the shell terminal. So this was the entire interpretation of the malicious VBA macro that was embedded inside the document. So this is where the delivery and exploitation phase happened. So in the delivery phase, this document came in as an attachment with the email. And once you launch that particular document, you basically execute this macro in the background and you just downloaded the malware and executed it on your system. And that was the exploitation phase. Let us try the other file as well, which is a docx file. It's called statements.docx. So here if you see, object number A3 contains VBA macros as marked by Oledump. So we'll go ahead and pass -s along with the object number, which is A3. If you press enter, it throws in a bunch of output in hex format. Let's quickly do a VBA decompress on this, and this results into the following script. So once you have the script with you, you can just start analyzing it once again, just like we did it in the previous video. So this is how we analyze malicious Office files using Oledump. In the next video, we'll try and understand how we can use the second tool to basically perform the same analysis. Hello everyone, and welcome to another video of expert malware analysis and reverse engineering. So moving ahead from our previous video where we analyzed a malicious Office file using Oledump, in this video we are going to focus on another very critical tool called Oletools. It's a very good tool and it's open source and it's specifically designed for analyzing OLE file formats. So here is the home page of Oletools. It has been developed by Tekalaj. You can read a lot about the documentation, about the setup, how you can have it ready and working. So there are multiple sub tools within Oletools as well, and here is an exhaustive list of all the tools that are present. We'll be going through a few of them in our current video. So how do we go ahead and install Oletools? Well, the easiest way is, if you are on a Linux machine, you simply run the command sudo-h pip install Oletools. That's it. That should be the command to install it on Linux. If you are on Windows and if you have PowerShell up and running and if you have set up Flare as well, pip will be working for you on the Windows environment as well, and you can run the same command to have Oletools installed on your machine. The other way is to go to the official GitHub page of Oletools. So that's the link for GitHub page, and you'll see the entire code base of Oletools here. If you go to the folder Oletools, you will see that all the subtools that we saw on the home page are mentioned here as Python files. So what we need to do here is to just click on clone or download and just download the zip file. Once you download and unzip it on your desktop, it will create a folder called Oletools master. So once that folder is present, just go to that directory. Let me just show you the folder once. So this will be the content of the folder. There will be a file called setup.py. So to have Oletools installed, just go to the particular directory where you have unzipped Oletools, given the command python setup.py and install. So once the installation goes through, Oletools will be ready to use on your computer. So once the entire setup is run, you will see that the Oletools folder now exists in your directory. You can either have this Oletools folder moved inside Flare Office so that it kind of makes it easy for you to keep track of all the Office file analysis tools, and later on you can reference them whenever you want. That would be a very ideal step because that will keep your tools in a very logical and arranged manner so that it's easy for you to look for them and use them whenever you need. So let us come back to PowerShell. Let's move to the Oletools directory. So some of the major tools that we want to cover here, the first one would be OLEID. Then we'll cover OLEmeta, OLEdir, OLEmap, and OLEVBA. There are a bunch of other tools as well, and I'll encourage you to just go ahead and play with them as well. So let us start with OLEID first. So the running of Oletools is pretty much the same as we did with Oledump. They all run with Python commands, so just pass Python oleid.py and just give it the location of your malicious document file. Okay. So once we press enter, it gives us a lot of information about the document file. So OLEID is a simple parser of a document file, and it looks for a bunch of traits inside the document file. For example, it checks whether the file is in OLE format or not, what's the application name on which it was built, whether it is encrypted or not, whether it contains any VBA macros or not, whether there is an Excel workbook. So this will happen when we analyze an Excel sheet. Then there are options for PowerPoint as well. It also checks whether there is an object pool or whether there are any flash objects which are embedded inside the document file or the OLE file. So this information can be very helpful in taking our next steps. For example, this says that the document file contains VBA macro. So this can be of suspicion for us that the macro might contain something which can lead to a malware download on the system. So the next tool that we want to look at is OLEmeta. What it does is that it basically gives you the meta information of the particular document file. So what I mean by meta information is basically the data about your data. For example, once you have a doc file, what kind of meta information can you get? You can get things like code page, title, is there any title that is associated with that document, who is the author of that document, what template was used to create it, who was the last person who edited or saved the document, how many times has it been revised, how many times has it been edited, when was it created, how many page numbers are there in that document. Now these are few informations which again requires some special attention. For example, number of pages. So it says that the document has only one page. So this again points to a suspicious activity, but because usually, I'm not saying that it will always be the case, but usually malicious documents don't really contain too much of content. All they care about is having the macro embedded inside it, and the document will contain either a simple image or probably some invoice kind of random information which should not go beyond like 1 or 2 pages. So having lower number of pages inside the document is an indication that the document might be suspicious. In our case, the number of words is 0, which further increases our suspicion. It means that there are no words, there is simply no text inside the document. Then what's really important about that document, that it was sent through email when there is nothing inside it? So that's another indicator which is clearly pointing us in the direction that this file might be suspicious. Number of characters is again 0. Further down, there are no lines, there are no paragraphs and nothing. So this is a very good way of kind of making a heuristic judgment inside your mind that, okay, this file can be bad. So this is how security analysts or security researchers operate. They look into these suspicious factors, and just by statically looking at the file, even without opening it, you are able to make a judgment that this file might contain something bad. The next tool that we want to talk about is Oledump, which basically gives you the directory representation of the OLE file. If you remember, when we were discussing about the file format of OLE compound files, we talked about how OLE files are arranged in a form of a parent root storage that consists of streams and further storages. Those storages are further divided into either streams or more storages. So this is what is represented here. If you see, there is a root entry that consists of bunch of streams and bunch of storage. The storage is for macros, and those storages in turn contain bunch of extra streams. So this basically, Oledump basically gives us the directory representation of the OLE file or the document file that we pass to it. Let's move on to another OLE tool called OLE map. So OLE map basically gives you a representation of the entire header or the entire information about the OLE file's internal structure. What OLE map does is that it reads the hexadecimal characters of the OLE file and it tries to map it against its attributes. For example, we again have that hexadecimal string here, which I asked you to look probably a few videos back. So this is basically the OLE file's signature in hex format. Then there are header, then minor versions, major versions, bytes, etc. So if you have followed the previous videos, these things will make a lot more sense to you. You can really understand why these information are there and what exactly they mean and things like that. The next tool that we want to cover is OLE VBA. So we have already figured out that the file is suspicious. It has only one page, it has no characters, but it does contain VBA macro, which definitely points that this can be something suspicious. So in order to go ahead and extract that macro file, we'll be using OLE VBA tool of Oletools. So once we pass OLE VBA, it goes ahead and extracts the VB script for us. This is exactly the same script which we extracted when we were using Oledump. The other advantage of using Oletools is that it also gives us some key indicators about the script that has been extracted. For example, it says that there is an auto execution and the keyword is document open. So what it means is that this VBA script will be executed as soon as someone opens this Word document. We discussed about this in Oledump as well. There is also presence of shell command execution, which definitely points that it is something suspicious. It may run an executable file or a system command. It also has been able to pick up PowerShell, where it says that it may run PowerShell commands. It may download files from the internet because it's calling net.web client. It will download file. It will create new object onto the system. And as an indicator of compromise, IOCs, so IOC stands for indicator of compromise, it says that this is one of the indicators that should be something you should look at. And there are a bunch of other IOCs picked up as well, like cmd.exe and two more file names, which are also executables. We'll be going into much more details as to what IOC means. For now, you can simply understand it that it represents some of the indicators which might lead to malicious activity or which might be associated with malicious activity related to a malware campaign. Another interesting tool that comes in the Oletools suite is MRaptor, which basically looks for any suspicious VBA macro inside your document file. So to run it, again we'll pass Python mraptor.py and we'll pass it our document file's location. So once it runs, it tells you that the result of execution of this tool was that the document file is suspicious, and the reason is because it contains a bunch of flags. And what are those flags? It says that it contains autoexec, it writes to disk, it executes something, and this is the reason why it is heuristically predicting that this file might be suspicious. So they have basically used their other tools to extract those informations, and they are applying a heuristic to give you a judgment that the file is suspicious. We have already seen how these heuristics have been determined and why they are suspicious, so it makes us much more sense to directly use MRaptor to figure out that this document file is suspicious or not. I did not directly go to MRaptor because I first wanted you all to understand what are the traits of a suspicious document file and how we basically extract the VBA macros to make sense out of it. And once you have that idea, it makes it much more easy to understand why this document file was particularly categorized as suspicious. So that was all about Oletools. Thanks a lot for watching. Welcome everyone to another video of expert malware analysis and reverse engineering course. In this video, we are going to analyze malicious PDF files. So before we dive into analyzing actual malicious PDF files like we did for Office files, we will first understand the PDF file structure. This will help us in building a stronger base in understanding how exactly the PDF file format looks like, how exactly it is structured, and how to understand its different components. PDF stands for Portable Document Format, and it is a file format to basically represent documents. It's a very simple file format. It basically can be called as a text format where everything is stored in the form of dictionaries, and the dictionaries contains information about the file, and it contains streams which holds the data about the PDF. For example, if you have image or if you have text, all those things will go inside the streams of the PDF. It encapsulates various elements of documents as objects, just like we mentioned right now. It will have different objects, and all those objects will contain properties of different elements inside the PDF, as well as the stream of data that is present in the PDF. Supports rich and interactive elements. For example, it supports images, it supports graphs, you can draw shapes inside it. Scripting capability as well. So PDF file formats are very much capable of supporting scripting languages like ActionScript and JavaScript. You can create dynamic elements and dynamic actions like filling up of forms, loading information dynamically, and things like that. In a PDF file, there are four major sections: header, body, cross-reference, and trailer. So let us try and understand what exactly these sections mean. So on the right hand side, you can see that there is a structure of a PDF file. In order to view the structure of any PDF file, you can just simply drag and drop the PDF file in a text editor and you can view the structure something similar to the one that I have here on the right hand side. So the first section of the PDF file is its header. So header is nothing but the magic number which denotes that this is a PDF file and it contains the version of the PDF file. If you see here at the top, it says that it's a PDF file of version 1.7. So following downwards, you will see a bunch of objects inside the PDF file. These objects basically constitute the different elements of the PDF file. So 1 basically denotes its name, 0 is its version number, and obj denotes the object. Beginning and ending of these signs basically represents a dictionary, and within those dictionaries you'll contain the different elements of the PDF file. Then we have end object, which basically denotes the end of object, and then there will be another object and so on. So this was the first part, which is header. The second part is the body. The third part is cross-reference, and fourth part is trailer. So the body basically constitutes of all these objects that are there inside the PDF. Let us talk about the cross-reference table here, which is our third important element of the PDF file and probably the most complicated one. Cross-reference table is nothing but a table that allows the PDF parser to quickly access every object inside the body. So it begins with xref, which denotes the cross-reference. Then 0 denotes the start of the object, and 4 denotes the number of objects which are there inside the body. So if you see here, we have 1, 2, and 3 objects. So the question is, why do we have 4 here? The answer is this root object over here. So every time the body will contain one less than the total count of the objects, because PDF also includes this root object as 1. So the total count of number of objects inside the PDF becomes 4. Now the cross-reference table has a standard format. So this denotes the offset from where the first object is starting. This denotes the offset from where the second object is starting, third, fourth. So 65535 is basically a 5-digit generation number. It's something that the PDF tool generates for you. And here F and N have two different meanings. For example, whether that object is a free object or whether that object is in use. The last part is the trailer part, the fourth important part of the PDF file. So the trailer contains the overall information about the PDF. So if you look here, it begins with the keyword start xref. Then it contains an integer. So this integer basically denotes the beginning of the cross-reference table. So it basically points to this location over here. So if it says 249, it means it's here. So there are 4 characters. It means 0 is at location 253. So that's how this table is denoted. And then finally, we have end of file, EOF, which tells that the PDF file has ended. So what exactly happens here? Once you load a PDF file into a PDF editor or into a PDF reader software like Adobe Reader, the PDF tool starts reading the file from the bottom. It first goes to start xref. It figures out the starting byte of the cross-reference table. It comes here. From there, it knows that there are 4 objects inside it. It picks up the location of the first object, which is pointed here. Then it comes to the root object where it says that it wants to go to object number 1, and the entire flow then jumps all the way to the top to object number 1. Then it reads the content of the object number 1, then it goes on to 2, 3, and so on. So this is how the parsing of a PDF file happens inside a PDF parsing tool. Here is another image that denotes the complete structure in a way how we just followed. So you have the header, then you have all the objects, then you have a cross-reference table. If you see here, the cross-reference tables are basically linked with all the object numbers, and then we have trailer, and then we have the end of file. So end of file basically contains the bytes from where the cross-reference table starts. So it points to basically the cross-reference table, and from cross-reference table we start parsing the objects. So this is how the entire structure of a PDF file works. Here is a hex representation of PDF files. Let us just load the PDF file into a hex editor. In my case, I have loaded it in 010 editor. You can see the same PDF structure that we just talked about. So the good thing with 010 editor is that it has bunch of file parsing templates. So it basically helps you in understanding the file formats in much better way. So 010 editor also has PDF template as well, which parses the PDF files and gives you more information about its different objects. So if you look here at the bottom, it tells you about the PDF's header. Then it tells you that there is a white space. Then it tells you that there is an object and its starting position is 10. So if you come back to our presentation, you will see that in the cross-reference table, position number 10 is basically pointing to the first object, right? So this is how we can verify that how the PDF file is parsed, what exactly the different locations mean. So you have 10 for the first one, you have 69 for the second, and you have 141 for the third object. If you go back here, you can see that they are exactly the same locations. So this helps us in better understanding the cross-reference table and how it has marked different memory locations. So this was all about PDF file structure. Starting from next videos, we'll start analyzing malicious files using different PDF analysis tools. Thanks for watching. Hello everyone, let us start analyzing a bunch of malicious PDF files. So again, we'll be coming back to our Flare suite of tools collection. You can see there is a folder for PDF. Once you go inside, you will find that there is a tool called PDF parser, which is critical in parsing the complete PDF file and extracting malicious artifacts out of it. Then there is a shortcut for PDF parser and there is a shortcut for PDF ID. So these are basically the compiled executables of the actual program. If you go inside PDF parser, you'll see that it's simply a Python file. We can run it just like we ran the other OLE file analysis tools in the previous videos. So PDF ID, its original tool is not here, so we can just click on the properties of the shortcut and we can see that where exactly this shortcut is pointing to. I can see that it's in program files, PDF ID. So I don't really enjoy running the shortcuts. It's better to always run the Python program directly, so that in case there is any error, you can look at it and try and resolve. So let's quickly go to program files, PDF ID, and just copy it and move it to the flares folder. So you now have both PDF parser and PDF ID in the same Flare directory. So PDF ID is more of a meta information tool which gives you a bunch of meta information about the PDF file. For example, how many page numbers are there any JavaScripts present inside it, and things like that. Whereas PDF parser is more of a dynamic parsing of the PDF file. So let's begin with using PDF ID first. So I'll come to my PDF ID directory, and my files are saved in course files, PDF example. I have 3 examples here, so we'll be using them one by one. So to run PDF ID, again we'll pass Python pdfid.py followed by the location of the file. So once we press enter, it will give us a bunch of information. For example, this PDF file has 26 objects inside it. If you remember from our previous discussion, we talked about how PDF file is basically the body of PDF file consists of different objects, and all those objects will begin with obj and will end with end obj. So there are 26 objects and 26 end objects, which means that it's properly ending all the objects. There are 9 streams. Again, the body of the PDF file contains streams, and these streams have the data. Then there is one cross reference, there is one trailer, one start xref. There are 3 page numbers. There is one JavaScript as well, /JS tag that has been picked up by PDF ID, and it has picked up 2 JavaScript tags as well. There is an open action as well. So what I mean by open action here is that once you launch the PDF file, whatever is marked with open action will be immediately executed. So it's very important to understand all these meta properties that we have got from PDF ID. We already know a bunch of them, but there are some of them which are new, and the important ones are things like JS, JavaScript, AA, open action, XFA, URI. So URI again tells us is there any URL that is present inside the PDF. The embedded file tells us is there any embedded file, for example an executable or a flash file that is there inside the PDF. So the interesting parts here are JavaScripts. We know that this file contains JavaScript, and there is an open action that is performed as well, which means that as soon as we are launching the PDF is trying to do something without giving you any kind of permission or something. All you have to do is just run that PDF itself. Let us run for our second file as well. So in the second file we get something similar. There are 12 objects, there are 2 streams, it has 2 pages, and again it has JavaScript inside it, and it performs open action as well, and there is no embedded file and there is no URI inside that PDF file. Let's try with our third example. Quite the similar result. We have 8 objects, 1 stream, 1 page. There is no JavaScript in this case, and there is one XFA, no URI, that's it. So this is how we first collect some kind of static information of the PDF file using PDF ID, and this can help us in making again some heuristic analysis of the PDF file by looking at the number of pages, whether it has some JavaScripts or not, whether it's performing some open action or not, and things like that. So once we have some kind of static heuristics about this PDF file, the next thing that we can do is we can start using PDF parser to actually look into these elements. So let's go to PDF parser. We'll again run it as python pdf parser.py. We'll again give the location of our file. So it's example1.pdf. We press enter and it throws a bunch of result to us. So the first result of PDF parser is nothing but the complete raw output of the PDF file. You can see that it begins with the PDF magic bytes, which tells us that it's a PDF file of version 1.4. Then we have objects inside it. You can just keep scrolling down. You can see there is one object that contains stream. As you move down, so there is another object. This might seem like suspicious, but you have to look at what's exactly there inside this particular dictionary. So it seems like it's a font setting element where this PDF has some specific font, and these are basically the hex representation of the value of that font. So it's not really something critical in terms of maliciousness of the file. Can further come down. So these objects that contain stream, these can be of interest, But as you see, these objects have been referenced, so we have to look who actually is trying to reference to these, or whether they are actually being referenced or they are just some placeholders. So if you move down, the object number 24 tells us that it's basically having a JavaScript, and the JavaScript is executing a URL with unescape. If you further move down, object 25, that's more about the title of PDF, and that's it. We have the end of file. Okay, in order to quickly search for anything inside the PDF, the option that PDF parser gives us is -s. With this parameter, you can search for any string inside the PDF. Let's say I want to look for JavaScript. So it tells me all the locations where JavaScript has been located. For example, object number 24 contains JavaScript, and it has the actual script as well. And there is another object, object number 26, which contains a dictionary that is calling the JavaScript and referencing to object number 23. So let us see what exactly is there in object number 26. I think that is going to be the same data that we see here, but let's run -o, which is for object, and pass it the object number, which is 26. So if you press enter, it gives us the content of object number 26. So again, the object number 26 says that it's trying to call a JavaScript that is at object number 23. So let's go to object 23 and see what's there. So object 3 is interesting here. It's not really doing anything. It is just referencing to object number 24. And do you guys know what is there at object number 24? It's our JavaScript that we just now saw. So this is basically a kind of way by which malware authors try to create a sort of loop so that the PDF tools are not able to quickly recognize where the JavaScript is located. So if you see, there was object 26. Object 26 was referencing to object number 23, and object number 23 referenced to object number 24, and it was object number 24 that actually contained the JavaScript inside it. So we have the JavaScript here. Now it's a simple unescape script. All you have to do is just append document.write to it, and you can see what exactly this JavaScript translates into. Let us quickly analyze another example. So again, it's a pretty long output, and we already have a result from PDF ID that example2.pdf also contains JavaScript. So let us search for it. Okay, so it's saying that there is a JavaScript that is referencing to an action. So let's search for action here, what exactly it does. Okay, so if we look at the referencing action, this JavaScript is trying to launch command.exe. From there, it's going to home drive, home path. It's looking whether template.pdf exists on the desktop or not. If that file exists, it's actually executing it. So this is what this JavaScript is trying to do. It's basically a launch action. As soon as you launch that PDF, this is the particular portion of the script that will get executed. So this is how we follow the trails and try and understand what the JavaScript is trying to do. Welcome back to another video. In the previous videos, we looked at a few command line tools for analyzing PDF files. We looked at PDF ID and how it can give us some meta information about the PDF file, and we also looked at PDF parser as to how we use them to analyze and extract different malicious components out of the PDF file. In this video, I want to quickly introduce you to another powerful tool, and it has a GUI interface as well. Again, it's a part of your Flare PDF repository, so you don't really have to download it from anywhere else. And in case if you don't have Flare set up, you can obviously download the tool. It's called PDF Stream Dumper. You can search it on Google and you can find the official link from where you can download it. So let us launch PDF Stream Dumper. It has a very simple UI and it has a bunch of options. It has a JavaScript UI, it has unscape selection. So this basically translates everything that is in unscape format. It helps you put your manual escapes as well. It looks for go-to object streams. It helps you search. It helps you find and replace. So these are some of the features of PDF Stream Dumper. Let us go ahead and open a PDF file and see how it looks in PDF Stream Dumper. So we'll launch our example1.pdf. So it basically lists all the objects in hierarchical order. So again, we start with the bottom part. If you remember our introductory video about PDF file formats, where we talked about PDF tools basically parsing the PDF files from downwards, where they first locate the cross-reference table and from there they start looking into the different objects. So if you look here, that's the root object, and then there are a bunch of other objects as well, and it says that the total count of objects is 27. So it means that the body will have some around 26 objects inside it. Okay, so let us come back to the first object on top here. Let us start just looking randomly into each of these objects and see what content they have. So this object basically contains a bunch of text. I think PDF Stream Dumper also translates the stream data, the raw stream data, into actual meaningful text, which is not possible when you are using PDF parser. So as we keep moving down, we'll see a bunch of information. Here is another stream of data present inside it. I'm mainly interested in the JavaScript element which we captured in while we were using PDF parser as well. Okay, so here is embedded JS, and it points to object number 24, and our object number 24 has the JavaScript. It's the same one that we saw in the previous video. So one good thing which we can do with PDF Stream Dumper is that we can basically select the unscape part, and we can just click on unscape selection and it will immediately give you the actual readable ASCII format of whatever was there in the unscape code. So this was not possible when we were doing with PDF Stream Dumper. We'll have to look into different ways. For example, we have to manually create a JavaScript file, just give document.write and pass this entire thing, and then it will translate. But here in PDF Stream Dumper, you can just do it automatically. All you have to do is just select the characters which are there inside the unscape and just click on unscape selection, and it will translate everything for you. So the another important feature that I wanted to show you is the JavaScript UI feature. So once you reach to the object where JavaScript is present, just click on the JavaScript UI and it will launch a separate panel, and you can see the JavaScript here. So in order to have it running, all you have to do is just get rid of the extra characters here and prepare a simple JavaScript out of it, and you can actually decode the entire thing yourself. In this example, the decoding element is pretty straightforward, so I don't think it will be very difficult to decode it even by using the unscape selection. But at times the JavaScripts can be really complicated, and that's where this JavaScript emulator can be really handy in PDF Stream Dumper. So we've got rid of extra characters. Let us see what else is extra here. So we don't need this .get URL. We have removed a bracket, so let's remove a bracket from here as well. The other two brackets are present, and let us add document.write and close the brackets. Now let us click on run, and that's it. Here you see the result of document.write, and that's the data that it actually prints. So people who are not familiar with JavaScript, document.write is nothing but a print statement which gives you an output of whatever you have typed inside it. So this is how you deobfuscate the JavaScript using PDF stream dumper. Thanks for watching. Hello everyone and welcome to another video of expert malware analysis and reverse engineering course. In this video, we are going to talk about packet capture and how we analyze those packet captures. So the bigger question first to answer is, what exactly is a packet capture? A packet capture is nothing but a replica of the traffic that is flowing over your network. It can either be through a single device, either your laptop or your desktop, or it can be a capture of the entire traffic of a network of different machines that are sitting in the network. So why packet captures? There is a popular saying in the information security community, or rather the network security community, that if you do not have packet capture of any security incident, just consider that the incident never happened. And this is said because packet captures can be really vital in investigating any breach or any security incident that might have happened inside the network. Packet captures can give a very clear indication as to what was the direction in which the traffic flowed, what are the machines that might have infected. You might be able to capture just one machine, but there can be many more machines that might have been infected through the same malware, and those things becomes easy to identify if you have the packet captures, because the malware will definitely be communicating outside with its host. So there will be some of the other network activity from all the infected machines, and that's where packet captures can be really useful in determining what all machines have been infected in the network. And that's where packet captures become one of the most vital resources when you are doing malware analysis or analyzing any security incident. So what can be the different aspects of packet captures? We can do small scale packet captures, which basically involves analysis of any existing protocol. For example, if you want to analyze the headers of, let's say, a DNS protocol, then you can do that using any kind of packet capturing tool. Or if, let's say, you are designing some new protocols, or if you are designing new tools that involves network communication, you can use packet captures for these kinds of activities. And there can be large scale packet captures as well. These involves traffic analysis and basically gaining statistics over your network, how much of traffic is flowing within your network, what is the classification of the traffic, and things like that. You can also do a lot of capacity planning using large scale network captures, and you can basically create and implement traffic policies around your network activity by using the captured packets. The third aspect is network attack and attack prevention, and that's where um, the malware analysis and the incident response people come into picture. So the packet captures can help you in identifying attacks. It can help you in designing rules, designing policies that can prevent attacks. It can help you in capturing of credentials which are not encrypted. It can also help you in setting up and applying security policies across your network. So what are the considerations for capturing packets? We have to make sure that we do not introduce any latency in the overall network because of our packet capturing, because we don't want the network to be slowed down because of the ongoing process of replicating the packet captures in your software or hardware. Your capture device can only capture traffic that reaches its network interface. You just cannot capture network traffic that is not hitting your interface. For example, if you are trying to capture traffic from your laptop, you're only going to capture the traffic that flows in and out of your laptop. You cannot really capture the traffic that is flowing in and out of, let's say, a second laptop that is being used in your home network. The usual behavior of packet capturing is that it will just filter out the traffic that doesn't match an interface address, and it only captures the traffic when there is a particular match. So these are some of the considerations for packet captures. Now, what are the ways by which the packet capture can be done? There can be two ways. One is hardware oriented, where you set up a separate appliance that is capable of capturing the packet in your network. The appliance is basically a custom host with multiple network interfaces. The appliance can be inserted into an existing network link, and once it's sitting inside your network, it can basically start capturing all the activities that are going on within your network. Most hardware appliances use software for their analysis. So these hardware tools have a lot of analysis capabilities as well. For example, they can give you an indication of the amount of traffic that is flowing in and out, what are the classifications of the traffic, which are the top talking hosts inside your network, and things like that. So usually for all these kinds of analysis, the hardware capturing devices use specialized softwares that are present inside them. The second type of capturing can be a software capture. An existing host has captured software installed on the machine, and it can help you in capturing the software, can help you in capturing the packets without needing any specialized hardware. And one most common example of this is packet capturing tools like TCP dump or Wireshark. We'll be going into much more details of software capturing in the later videos. The host interference is operated promiscuously. So what this means is that basically the filtering of packets is completely disabled. So this allows the software packet capturing tool to capture all packets without dropping anything. We have the example of capture scenarios. So if you look here, the diagram on the entire left is basically an hardware capturing scenario where you have a separate hardware that sits at the entry point of your network. The data basically enters from the left. It goes into the hardware where you have a 3-port bridge. From there, a copy of the packet capture is saved onto the disk, and then there is an analyzer software that does the networking analysis work. And after that, the traffic basically goes into the network. On the right hand side, if you look at the top, it's basically a normal capturing scenario where promiscuous mode is not enabled. So you're basically bridging the network and the host so that whatever traffic comes in and goes out gets basically captured. Something similar happens in the promiscuous mode as well, where you have a software-based packet capturing where you are again bridging your interface and your host to intercept all the traffic that goes in and out. So this was just a quick representation of how exactly the packet capture can happen in different scenarios. We will be more focusing on local software packet capturing scenarios, and the same concepts and same ideas can be implemented on large scale hardware captures as well. So one tool that is very helpful in packet capturing is Wireshark. It's a free protocol analyzer software that is available for both Windows and Linux platforms. And in the later videos, we'll start going into much more details of Wireshark and how to set it up in our virtual environment and how we can begin capturing packets using it. So this was a quick introduction to packet captures. That's it for this video. Thanks a lot for watching.
Hello everyone, and welcome to another video of expert malware analysis and reverse engineering. Continuing from our previous video, in this video we are going to give a quick introduction to Wireshark. So what is Wireshark? Wireshark is a network packet and a protocol analysis tool. It helps you in capturing the packets that are going in and out of your network, and you can basically dissect into those packets, and you can look at all the headers and the information that is basically contained in those packets. Wireshark is perhaps one of the best open source packet analyzers that is available today for Unix and Windows. It's used for network troubleshooting, analysis softwares, and communication protocol development, as well as education. Some intended purposes of Wireshark, well, it's used by network administrators to troubleshoot the network problems, and it's also used by security analysts to uncover different security traits of infections on a system. Developers use it to debug protocol implementations. People use it to learn network protocol internals, and so on. Wireshark is not really an intrusion detection system. A lot of people have this misconception, but it's not really an intrusion detection system. All it does is that it basically gives you a replica of all the packets that are flowing in your network. So here is a quick system overview of Wireshark. Let's say you have a endpoint sitting here. So if we expand the diagram, and if you look on the complete right hand side, you will see that there are the 4 layers of the OSI model, and the first layer is the physical layer. So this is where your entry point or exit point to the network starts or ends, right? So if you look here on the left, this is the point which has been marked here. So the data gets in here and exits from here as well. So what Wireshark does is that it basically sits at the link level where your Ethernet is present, the hardware Ethernet in your system. It sits here and it copies all the Ethernet frames that are sent and received, and it kind of creates a packet capture or a PCAP file. So once the capture is done, the UI can then use a packet analyzer to display you the result. So everything here basically works along with the operating system. So once you have some kind of data coming in, let's say you visit google.com, you will send a request out and then a response will come back in and all the way to your web browser. So once your request goes out, it gets captured here, and once a response comes in, it gets captured here as well. So the PCAP will contain both the request and response pairs that are going in and out of your network. So downloading and installing Wireshark is pretty straightforward. You can just go to wireshark.org and you can download it from there, and you can get the latest version. Wireshark will install all the dependencies for you as well, so you don't really have to worry about those things. The last I checked, I don't think it gets installed with Flare. But you can obviously check with your machine and see whether Flare supports Wireshark or not. If not, you can easily download it from here, a much more updated version, and it's pretty straightforward. You just run the executable and you'll have Wireshark up and running on your machine. So once you're done with the installation part, once you launch Wireshark, you will see something similar to the image shown here. So there are a few basic pointers that I wanted to go through. So at the top, once the GUI starts, the top part basically shows you the command menus. Then you'll see that there is a bar as well where you can type in. So this bar is your display filter, where you can apply different filters in order to look at specific traffic that has been captured by Wireshark. We'll be going into much more details about how filter works. It's a very critical part of analyzing PCAPs. So we will be doing a separate session completely on display filters and how to write your own filters to look at traffic and analyze what data is present in it. Then below here is the actual captured traffic. Once you apply some filters here, you will see the result of the filter here. If you don't apply anything, you will just see the entire captured traffic. Then the details of the individual packets can be seen here, the details window. This is also a very important window where you can get much more details. You can drill down into the packets. For example, if you see here, there is a drill down of HTTP requests. So you can see all the HTTP headers here. For example, there is host information, there is user agent, there is encoding, connections, referrer, cookie, and all those informations are present here. So you can drill down to the HTTP request and you can look at each of the headers and see what information has been transferred. And lower down is the packet content in hexadecimal format. So you'll have both hex as well as ASCII representation here. So you can compare the data both at hex as well as ASCII level. Moving ahead, so once you launch Wireshark, it's very critical to make sure that you are capturing traffic from the right interface. So if you are connected with wireless internet, you have to make sure that you are capturing your wireless data. If you are connected with an Ethernet cable, you have to make sure that you capture the data on the Ethernet cable. So Wireshark makes it easy for you, the newer versions. Once you launch Wireshark and once you go to interfaces, the option that is shown here, if you click on captures and if you go to interfaces, it will show all the interfaces that it thinks exist on your machine, and it will tell you which of those interfaces are active. So if you are using a Wi-Fi, you'll automatically see that the Wi-Fi interface will show you a graph which shows that okay, there is some live traffic going on. So you can just click on it and you can begin the capture. Okay, so here I have an example of all the interfaces as well. So in this case, you can see that there is a gigabit Ethernet interface, and there are two VMware virtual Ethernet adapters as well, which can help me in capturing the traffic of my virtual machines. So if you can see, the Ethernet is having lots of packets going in and out. So I can just click on start and it will begin capturing the packets for me. So the entire capture is basically split into three parts. One is the packet list panel. So this is basically the list of packets in the current capture, and they all are color coded. So Wireshark uses a lot of color codes to denote different packets. For example, for HTTP it will use green color, for DNS it will use gray color, and so on. So that's the packet list panel. Then you have the packet details panel, where you have all the details of each packet. You can just select one packet and it will give you much more details. You can drill down, pretty much like what we saw in the previous slide. Then there is a packet bytes panel as well, which shows you the packet bytes in ASCII and ASCII coding. So here is a snapshot of what I was mentioning in the previous slide. You have a packet list panel where you have all the packets which are color coded. So you can see that there are green for HTTP, for TCP, then there are gray ones, there are blue ones for UDP. So that's how Wireshark intelligently creates color codings to make sure that they are able to separate different protocols based on colors as well, so that it's easy for you to interpret them. Then you have the packet details panel, where you can drill down to the individual packets that you select here. And at last you have the packet bytes panel, which basically gives you hex and ASCII representation of the packet bytes. So once you are done with capturing the data, never forget to just click on the stop button so that it stops the packet capture. Otherwise it will just keep going on and on forever. So make sure that you click on the stop button so that it can stop your packet capture. And then you can just go ahead and save it as a PCAP file. You can transfer it to someone else who wants to look at the PCAP, and you can use it as evidence for whatever type of examination you are doing. So this was a brief introduction to Wireshark. In the later videos, we are going to do a demo on how we can capture Wireshark, and then we'll proceed into analyzing suspicious or malicious traffic using Wireshark. That's it for this video. Thanks a lot, guys. Hello everyone, and welcome to another video of our course. In this video, we are going to talk a bit more about Wireshark display filters. And once we get a basic understanding of how display filters work, we'll move to demo exercises where we'll start working with capturing packets and applying those filters. So what exactly is Wireshark display filters? So filters lets you look at specific traffic. For example, if you only want to look at all the DNS requests that you have made and you don't want to look at TCP requests, you can apply a DNS filter so that Wireshark will only show you all the DNS traffic that has been captured for the given session. So this is what filters does for you. It's basically post filters. Once you have the packet captured, you can apply those filters to view that filtered result. Or if, let's say, you are only interested in looking at the live DNS request, then you can start a live capture, you can apply the filter, and GUI will only show you the packets that gets matched with your filters. One thing to keep in mind is that the filters only filters out the traffic. It doesn't delete the remaining part. The remaining PCAP or the remaining capture still remains. It's just that the display filter kind of narrows down to the specific request that you have made using the filters. So display filters have their own format, and they are much more powerful than the capture filters. So in the previous video, we saw where display filters location is in the UI. So you can see that there will be a filter tab where you can just provide your display filter, and the display panel here will basically list the result of the filter that you have applied. So the most basic way is to just write the name of any protocol that you want to filter. For example, if you want to look at DNS traffic, you can just enter DNS and press enter, and it will only show you all the DNS requests that has been made by your
machine. Similarly, you can pass TCP, HTTP, and so on to look at specific captures of data. So Wireshark display filter has a very specific format. Here I have broken a filter into its specific sections. So first you provide the protocol. For example, here I am providing FTP, and then you can put dots to concatenate different string operations. For example, the string 1 is passive and string 2 is IP, and then you can pass the comparison operator. What do you want to look at? Do you want to look at specific IP? Do you want to look at conditional matches and things like that? For example, in this case, I want to get a specific match for IP address 10.2.3.4, and then you can further add logical operators, and you can add multiple expressions going forward. You can either end right here at the value once you feel that, okay, this is the only data that you need, then this should be your filter. For example, let's say you only want to look at IP 10.2.3.4, then you can just have this much data provided and you'll get your result. And you can keep on expanding the filters by just concatenating them following this particular logic. So this is how the display filters are arranged by Wireshark. So if the filter that you have provided, for example, TCP.port equals to 100, if this filter is correct and recognizable by Wireshark, you'll see that the bar turns to green color, which means that it's the correct syntax. And if the bar remains as red in color, it means that your syntax is wrong, and probably you might have to look for the right way of writing your filter. So this is a very good indication right at the filter level itself that Wireshark provides you, so that you don't really have to run it and then wait for wrong results and then say that, oh, your filter was wrong. So it kind of runs a static check here itself, and it tells you whether your filter is correct or not. So it's basically checking the syntax. If your syntax is correct, then it will obviously turn to green. If the syntax is wrong, it will turn to red. So here is a pro tip for you guys. There is an excellent cheat sheet that has been created by packetlife.net. It has all the important Wireshark display filters in this one single PDF, which you can obviously refer back whenever you are working with Wireshark. I have also attached this PDF as a resource for you with this video. You can go to the resources section and you can download it from there. And this cheat sheet is really handy when we will be looking at some of the malicious PCAPs in the later videos. The other important thing that I wanted to bring up is the follow stream option in Wireshark. So if, let's say, you are collecting a bunch of streams, let's say you are using your browser to visit all kinds of websites, and at a given time you let's say visited 10 different websites. If you look at the PCAP, it will have all the packets that have been captured at any given interval. It would not have the serial capture display. For example, if you were visiting google.com and at the same time if you visit cnn.com as well, then the packet capture will have all those packets displayed in all the random sequences. There will be a request to Google, all of a sudden there will be a request to CNN, and the response for Google, then a response for CNN, and so on. So what do you do if you, let's say, only want to look at the traffic that relates with google.com? That's where follow TCP stream comes into picture. So let's say you see that, okay, I have sent a request to google.com and I want to see what response came back. You can just right click on it and you can go to follow stream, and it will basically show you the entire stream of data. Here the red marked text is basically the request that you send, and the blue part is the response that you got back from the server. So this is what follow stream helps you with. It kind of aggregates the entire communication into a single window so that it becomes easy for you to analyze it. Saving packet filters, you can just click on file and you can just click on save as, or you can export it into various different PCAP formats that are supported by Wireshark and other packet capturing tools as well. It's always advisable to keep a copy of your packet captures because they serve as an important and critical evidence for your forensics and malware analysis work. So there is another handy option in Wireshark called Wireshark Statistics. if you have a packet captured with you, you can just go to Wireshark statistics. It gives you information about what kind of packet has been captured by Wireshark till the time you ran the packet capture. It will tell you how many TCP packets were captured, how many DNS requests were made, and a lot of advanced statistics as well, which can be very helpful when you are analyzing complex packets or when you are analyzing packets which are very huge in size. In that case, Wireshark statistics play a very critical role in giving you a rough idea about what kind of packet mostly constitutes in the particular PCAP file. Here is another view where you get an entire flow graph of your packet captures. You can just go and launch Wireshark and you can start playing with all these features in Wireshark. So that's it for this video. See you later. Bye-bye. Welcome back, everyone. Let us do a quick demo on Wireshark and see how exactly Wireshark captures packet. So we can go to start, we can type Wireshark, we can right click on it, and we can open it as an administrator. Click on yes. The UI loads and you can see all the capture interfaces that Wireshark was able to figure out. If you see on the local area correction, that's where the traffic is currently flowing from my virtual machine and going all the way out through my Ethernet to the internet. So I can just double click on it and it will start capturing the packets for me. You'll see there is a bunch of activity going on. There is some Microsoft update activities going on as well, which got captured. Let's go to Chrome and just visit any website and come back to Wireshark. You'll see a bunch of DNS requests and a lot of other internet activity. When you launch Wireshark, you will see that it's capturing a lot of traffic. So your machine is constantly doing some of the other network activity like operating system updates, some application trying to update itself, or your browser is trying to update the add-ons or trying to make some connection to check if there are new versions available and things like that. So Wireshark will constantly capture a lot of information once you start it. So let's wait for a while so that we have enough traffic captured. And once we are done with capturing, we can click on stop and the packet capture will stop. Now let us come to the display filter that we talked about in previous few videos. So to begin with, let's just look at all the DNS requests that were made. So if you can see here, we have requests to Microsoft, we have requests to Google, we have requests to Rediff. That was the one that was made through our browser. And if you keep scrolling down, you'll notice a lot of different requests. For example, Rediff tried to launch emails, it launched some ads, it went to books.rediff.com and so on. So that's all the DNS requests that was captured by Wireshark while the session was active. Similarly, we can go to HTTP requests, press enter, and it will give us all the HTTP requests that were made during the session. You can see there was a Microsoft update request, then there were a few more HTTP requests made directly to a web page, then there are some Chrome browser requests, then Rediff made some specific requests. So these are usually the subsidiary redirects that a website does once you make a request to a website. For example, we typed rediff.com, but rediff.com internally calls a lot of different websites. For example, if you look here, there is a get request that was made to an image. So this image might be there on the web page, and Rediff tries to fetch that image from its server, and that's why it gets captured as a get request. So this is how you can look at all the HTTP packets. You can also look at all the TCP packets similarly, and here you'll get much more details about the TCP data that went in and out. So if you look here, this is the first GET request that we made to rediff.com using our web browser. Now the 3 TCP requests right above it are pretty interesting. If you look at the first one, you'll see that it's a SYN request that went from your machine to the server. Then there is a SYN ACK packet which was sent by the server back to your machine. And finally, there was an ACK package which was sent from you to the particular server. So what exactly this is? If you guessed correctly, this is the TCP three-way handshake. It's basically a method used in TCP/IP networks to create a connection between a local host and a server. It's a three-step method that requires both the client and servers to exchange SYN and ACK packets before the actual data communication begins. So once the three-way handshake is successful, that's when you get a response of your GET request. I'll create a small exercise on three-way handshake for this video so that you can read more about it in much more details. So this is how you can basically interact with your UI, Wireshark UI, and you can understand what is actually going on inside your network. Scrolling down, here, if you look down, you have the transmission, the TCP control protocols details. So you have the source port, the destination ports, then you'll have source IP, you'll have destination IP, you'll have all different flags, you'll have options, you'll have sequence and analysis. So these are nothing but all the different headers that constitutes a TCP packet. So if you read about TCP or if you read about TCP headers, these are the fields that you are going to see in it. You'll see source ports, you'll see destination port, you'll have information about sequence numbers. So what sequence number tells you is if a packet transmits and if it gets divided into different chunks, then they will all have different sequence numbers. So this is what the sequence number tab contains, that information for you. So let's try something else. For example, if let's say we want to see all the GET requests, the GET HTTP requests that were made from this machine. So we'll type TCP contains GET and we'll press enter. So this is a string match which says that give me all the TCP packets that contains GET in it. So this is where we get all the GET requests that were made through our machine. Similarly, if let's say you want to know about the traffic going in and out to a specific IP address, for example, let's say 23.6.199.10, and you can type here ip.addr equals 23.6.199.10. You can press enter and you get everything filtered out based on the IP address. So this is how display filters help you in narrowing down your traffic to look for specific information or to look for specific packets that can help you in answering the questions in much more detail. So this was a quick demo about Wireshark. That's it for this video. Thanks a lot. Hello everyone, and welcome to another video of malware analysis and reverse engineering course. In this video, we are going to talk about exploit kits. So exploit kit is a very popular mechanism which is used by attackers as a delivery phase. In the spam emails, we discussed about two types of spams. One was spearphishing and one was the regular spam. So spearphishing was more like a targeted spam email which should be sent to specific organizations or specific individuals within an organization, whereas a generic spam will be more like email that gets sent to a bunch of users. In the same way, exploit kits are not usually targeted. They are basically hosted on a compromised website, or they would be hosted on an ad server by compromising the scripts of the ad. So the aim of the exploit kits is to infect as many users as possible. So if you look here, I have tried to denote the traditional campaigns that were used by exploit kits. So they would usually host the script on one of the compromised websites from where the attack will get redirected to the exploit kit server. Recently, we have started seeing that the exploit kits have started using multiple redirects in order to evade the intrusion detection and prevention systems. So what happens is you'll visit a normal website, for example, a news website or probably a video hosting website. Usually these websites will contain some kind of ads in different sections of the web page. So the attackers are trying to weaponize those ads in order to land you to the exploit kit server. So your website will redirect you to an ad, and the ad will basically redirect you to multiple TDS gateways. So TDS gateways are nothing but load balancing gateways that can help in redirecting traffic from one server to another. So exploit kits use this technique to basically perform multiple redirects before the user gets infected by an exploit kit by visiting the normal website. So here is a snapshot of an exploit kit traffic. Just to make it simple, let us consider that we already know that the exploit kit server is hosted on 185.158.153.204. So I'm using this presentation to give you a rough idea about what kind of filters you can apply when you have been given a PCAP that contains exploit kit traffic. And what should be your filters? How would you figure out that this was an exploit kit attack? What were the exploits that were launched and stuff like that? So let us say we know that this is the culprit IP. So what we can do here is that we can apply a filter at the PCAP which says that http.request and IP address equals to the culprit IP. So what we are doing here is that we are looking for all types of HTTP requests, whether it's a GET or POST, that have originated from this particular IP address. So if you look here, we have all the GET requests, 3 GET requests that have being originated from the particular IP address. So this is one very critical filter to quickly see what all requests were made by your machine to this particular server. So in exploit kits, the flow of event is very straightforward. What they do is that once you reach the landing page basically would contain a very obfuscated script, and this script tries to enumerate your browser plugins and your browser environment. For example, if you are using an Internet Explorer browser, the exploit kit will try and launch an Internet Explorer exploit onto your machine so that they can exploit the Internet Explorer and they can get an elevated privilege. On the other hand, let's say you are using Chrome or Firefox, the picture can be slightly different. The landing page of the exploit kit will be reached by following all those multiple TDS redirects and all. Once you reach the landing page will enumerate the browser. It will try and figure out what all plugins are integrated in your browser. For example, do you have a Flash plugin? Do you have a PDF reader plugin? Do you have a Java reader plugin? Do you have Silverlight plugins and things like that? So these are some of the common plugins that the exploit kits usually target, and they have bunch of exploits hosted on their server. So once the landing page is able to figure out the version of your plugins, it sends that information back to the exploit kit server. For example, let's say the exploit kit was able to figure out that you are using PDF version 13, which might be a vulnerable version. You might be using Java 7.4 or something like that, which might again be a vulnerable version. So once these details are sent to the exploit kit server, the exploit kit server goes ahead and launches the exploit based on these versions, because not all exploits are designed to directly infect any version unless it's a 0-day. So what exploit kit authors do is that they first figure out what is the version of services that are plugins that are hosted on your browser. Once they have that information, they would launch the specific exploit, and once the exploitation is successful, the attacker is basically able to bypass the sandbox environment that the browser has created. So this is the reason why exploit kits need to exploit your browser, because a browser environment is a sandbox environment and it has very limited functions onto the machine. Once it gets exploited, the browser process now has the ability to basically perform a lot more actions. For example, downloading the payload. So this is why exploit kits rely heavily on exploits in order to drop their final payloads. So coming back to exploit kit traffic, let us say we already figured out that what were the HTTP requests that came from the IP. The other query that we can look for is what was the response, or what was the request response pair from that particular IP. So we can write a filter which says that HTTP request or HTTP response that were from IP address 185.158.153.204. So if you look at the PCAP snapshot now, you'll see that there is a GET request, then followed by a response which contained 49,595 bytes. Then there was another request to a pretty long and weird URI pattern that was followed by another text HTML response. Then there was another pretty long GET request. The URI is pretty long and it's followed by another response which is basically an application XMS download MIME type. So this is how you can see what was the request and what was the corresponding response that came back to you. So from this query, we have an idea that there were 3 malicious requests made and they all resulted into successful responses, where 2 of them seems like text HTML pages and the last one looks like an application or probably an exe or something like that. You can further right click on one of those requests, click on follow TCP stream to further drill down into what happened. So let us say we right click on the first request and go to follow TCP stream to see what happened. So this will launch the request response pair in the Wireshark GUI, and you can see that this is the long GET request. It's pretty long. It has lot of characters. The interesting part here is the refer field. It says that the traffic has been referred from this particular domain, and this pretty much looks like a TDS server. Now you can go back to your PCAP, look for this IP address, look for this particular PHP script, and you can see what exactly is there inside it. So once again, once you reach to that GET request, you can right click on it, follow TCP stream, and you'll see that this web page is pretty small and all it contains is an iframe. So iframe is nothing but redirecting your traffic to the particular source that has been mentioned in the iframe. So this is how the attacker sends the traffic from a legitimate website using TDS all the way to the exploit server. Coming back to our exploit kit page, you can basically look at the content of the landing page as well. Most of the time it's going to be heavily obfuscated and it's going to be very challenging to deobfuscate them. It's not easy, it's pretty complicated. You'll have to do some advanced browser based debuggings in order to really get the actual script or the actual HTML page which will contain all the enumeration scripts in much more readable format. So here is another example of how exploit kit's obfuscation would be visible to you in a text pad. Now looking to our another GET request, you'll see that this GET request is nothing but an application shockwave flash. So what is happening in this case is that once the browser was able to figure out that you have a vulnerable version of Flash Player running on your machine, it basically sent you a Flash exploit. There are 2 ways of identifying it. In fact, there are 3 ways of identifying it. One can be directly from the GET request. If the GET request contains a .swf extension, we can say that, okay, this is a Flash file. But in this case, if you see, there is no extension. It's a pretty long URI that and it doesn't really contain a .swf extension. So from here, we were not able to identify that this was a flash file. Coming down in the response, you can look at the content type field, which basically points that this is nothing but a shockwave file. The third way is to look at the magic bytes. So for flash files, the magic bytes is CWS. In fact, there are two different magic bytes for flash files. One is CWS, which is compressed, and the other is FWS. They both are basically proprietary shockwave flash file formats. So we will go into much more details as to how we can individually analyze these exploits. For the time being, let's focus on the malicious traffic or the malicious exploit kit traffic itself. Okay, so this was a quick demonstration on how we could look at the request response, how we can look at what malicious traffic was served by the exploit kits, what was the actual exploit that was launched on the browser. And once you have the IP address, you can also figure out what's the host, and you can also write filters based on the host as well. You can also look at all the HTTP requests. So what happens is once your machine has been infected, or once the exploit was successful and a payload was dropped on your machine, you might want to look at all the HTTP requests that gets generated from your machine, because once the payload is there on your machines, once it's executed, it will start making a lot more GET requests, and that's where searching based on IP or searching based on host name would not really help you much. So you can look at an HTTP request filter to basically see what all request response pairs, what all requests were made on your machine. Another way would be to just filter out the traffic based on timestamp. If let's say you know that the first GET request was made at 23:15, then you can basically filter all your traffic all from 23:15 all the way to, let's say, 5 or 6 minutes. So that will give you a much more clear understanding as to what were the traffics that were specifically generated by the exploit kit, because a lot of times the PCAPs can be really huge. They can contain a lot of network data. So filtering the traffic based on timestamp would again be a very helpful way of narrowing down your search directly to the information that you're looking at. So this was all about exploit kits. In the next video, we'll start analyzing and playing with some PCAPs that contains exploit kit traffic. Thanks for watching the video. Welcome back everyone to another video of expert malware analysis and reverse engineering course. In this video, we are going to do a demo of how we can analyze a suspicious or malicious PCAP that contains exploit kit traffic. So in the previous few videos, we talked about Wireshark, we talked about packet captures, we talked about filters and how we can narrow down our search results, and we also talked about exploit kits as a delivery mechanism. In this demo, we are going to combine all these aspects, where we are going to look at a PCAP in Wireshark, and we'll be applying bunch of filters to basically analyze and extract elements out of that PCAP. So one of the good resources for downloading PCAPs can be this website called malwaretrafficanalysis.net. This website is an excellent resource for PCAPs that are explicitly related with exploit kits, malwares, and spams. So this website contains a collection of around 1500 PCAP samples. You can download them and you can start analyzing those PCAPs to understand how malware traffics are captured and how exploit kits can be analyzed. It contains a lot of different scenarios about exploit kits, spams, ransomwares, etc. So all those PCAPs can be really helpful for you to analyze and get more hands-on experience over analyzing malicious packet captures. So just wanted to bring up that all these download activities and analysis activities should be carried out in your virtual environment. So as you can see, currently I'm in my Windows environment, and I have downloaded one of the PCAPs from the website, and here is the PCAP loaded in Wireshark. So we can begin by looking at all the HTTP request and response. So here is my filter. If I press enter, it shows that there is a GET request followed by another GET request that has a pretty long and weird URI pattern, something similar to what we saw in our previous videos. So this URI pattern, it doesn't mean that it's actually bad, but it does point to some suspicious activity, because a lot of times exploit kits have these kind of weird URI patterns. So this was followed by a response which came out to be a text HTML. So most probably this might be the landing page. There is another request that is followed by a text HTML. So probably this is another response that came back from the exploit kit. Again, it can either be a landing page or probably some subset of response that was delivered back to us. And there is another GET request which is followed by a response that has MIME type of shockwave flash. So it seems like after the exploit kit was able to enumerate our machine, it figured out that okay, the browser contains a vulnerable version of Adobe Flash. That's why it downloaded a Flash exploit onto the machine. And there is another GET request. This seems like to be related with the payload download, because immediately after this request we are seeing some post activities as well. So why post activities are interesting here is because once a malware or the final payload is dropped onto the system, the malware will start performing its command and control by sending signals to its server, and that's where it tries to post some data to its command and control server. That's why these post requests can be really interesting to look at. So let us start by examining the first GET request. So we can go to follow HTTP stream or TCP stream. So if you see here, it seems like the individual visited this website, and this was the response. And if you look at the code closely, it seems like a pretty normal HTML code. So you have to figure out the location from where the infection might have started. So if you scroll all the way to the down, you'll see that there is a JavaScript that is present at the very end. This JavaScript seems to be creating an iframe. As you can see, it's defining a variable TQISD with iframe, and then it is creating an element with the same variable name. So it's basically trying to construct an iframe with this width, height, and 0 pixel border, and the iframe is pointing to this particular HTTP request, and this seems to be exactly like the GET request which we just saw in our PCAPs. So probably this is where the infection actually is beginning from. Now, one thing which I want to bring here is that because this JavaScript is present all the way at the end of the HTML code of this website, it's highly likely that this website might be compromised by the attackers and they have injected this code into this website. A lot of times popular content management systems like WordPress or Drupal, etc., they have a bunch of vulnerabilities, or probably one of their plugins will have some vulnerability that the attackers might use and compromise your website. And once they compromise it, they can inject these kinds of scripts into them so that any traffic that comes to your website will basically get infected by exploit kits. So let us go back to our request and response pair. So that's the first one which we looked at. This led to this second get request. Let us right click on it, go to follow HTTP stream. Now if you follow the HTTP stream, it shows that this was the get request, and it's the same one which we saw in the injected script in the main website in the previous get request. So this is your host. We got a response, and it seems like this web page is also containing an iframe and a JavaScript which is pointing to another malicious URL. If you scroll down further, you'll see that there are certain scripts which are basically trying to enumerate browser, trying to look at user agent. So all these scripts are pretty legitimate, and attackers use these scripts to figure out your browser, figure out the version of your browsers, figure out the plugins that are there in your browser. If you continue scrolling down, you will see that there is a post request, and the response is a very obfuscated script. So this seems like the landing page of the exploit kit. As you can see, this is heavily obfuscated and literally nothing can be read in plain text here. So this is why exploit kits are really hard to track or really difficult to understand, because of their heavy obfuscation and multiple levels of steps involved. It's not easy to track them when you have a very long PCAP file. So going back to our request response pair, so we looked at this request. Now let's check this one, and seems like its response is a flash file. So again, we can go to follow HTTP stream, and as we guessed, this is a shockwave flash file, and the magic byte is CWS. It means it's a compressed flash file. So what do we do here? Let's say if we want to analyze this flash file, what we can do here is we can go to file, we can go to export objects and select HTTP. Once we select HTTP, we can select request that shows that it's an application shockwave file. We can click on save, and we can save it probably, let's say, on our desktop, and we can name it as malicious.swf, and we can save this flash file. Similarly, if let's say you want to save the HTML pages that we just analyzed, you can just select them and you can click on save, just like we just did with shockwave flash file. So if you want to analyze the exploit kit's landing pages or the browser enumeration scripts, you can similarly save them here, and you can play with them in the deobfuscation tools. So let's close this and go back to our request response. So we know that this was our flash exploit. Now there is another get request, and it seems like there was no response associated with it. So we can just close it off. So this is how we can analyze a PCAP to figure out whether it contains any traces of exploit kit activity or not. So this was a quick demo about how we can analyze exploit kits. In the later videos, we'll begin analyzing the suspicious flash files and other malwares that gets downloaded from the exploit kits. Thanks for watching.
Hello everyone, welcome to another video of malware analysis and reverse engineering course. Starting from this particular video, we are now going to focus on portable executable file formats, which are basically executable files for Windows operating system. So if you remember, in our previous videos, we primarily focused on understanding the cyberkill chain to really understand how a cybercrime operation works in the digital space. After that, we looked at some of the common delivery mechanisms by which malwares or weaponized files can be delivered onto your system. We looked at things like analyzing spearphishing emails, looking at email headers and stuff like that. After that, we looked at emails attachments, which consisted of things like document files or PDF files. We then looked at the structure of these document files to really understand how we can analyze whether there is something suspicious or bad inside the file. Now what happens is, we all know that spearphishing is one of the most common ways of delivering malware onto your system. Now, usually those spearphishing emails would either have a document file as an attachment, or it may contain an hyperlink which when you click would redirect you to
probably some website where a document is hosted, and from there it would just try and download the document and execute it on your machine. So document files basically serve as the first level payload or the entry point onto the system. Those document files would not be the actual malwares that will infect your machine. They will be the first level payloads which will serve as the delivery mechanism for the second stage payload. The second stage payload is the actual malware. It's actually an executable file, a binary file which will run on your Windows operating systems. Just to give you an example, there is a difference between how you install a software and how you modify a document onto your machine, right? In case of document modification, you load a document in a secondary software and you edit the document, you save it, and that's it. Whereas in case of a software, you actually install it onto your machine because it requires certain special rights before it can run on your machine. That's the reason why documents can only serve as a delivery mechanism. A weaponized document can help deliver an executable malware onto your machine. But unless that executable doesn't land onto your machine is still not completely infected. So that's why analyzing portable executable files is the most crucial part of malware analysis. So the processes and steps that we learned in the previous videos was more like a stepping stone, because I do not want to directly jump into analyzing executable files. I want you guys to really understand the flow as to how an attack happens, and that way you can better respond to threats. So moving forward, we are primarily going to focus on executable files, especially on Windows machines. So PE file format, or portable executable file format. What exactly is a PE file? So portable executable files are nothing but a data structure format for executables, object codes, and DLLs in Windows operating systems. It can work for both 64 as well as 32 bits. So every executable that exists on the Windows file is a portable executable file. It has to be in that structure so that Windows can really understand that, okay, it's an executable file. Let's run it, let's load it into the memory, link its different drivers or link it with different required DLLs and start executing it to really see what that executable wants to do on the machine. So all the softwares, everything that you install on your Windows machine is nothing but a portable executable file. DLLs are also of portable executable file format because DLLs are also a kind of executables. So DLL basically stands for dynamic link libraries. They are nothing but reusable codes that are present in the Windows environment, which you can create if you want to create, which you can use if you want to create softwares on the Windows operating systems. So a PE file consists of a number of headers and sections that tells the Windows dynamic linker about how to map that file into the memory. So what happens is when you run a portable executable file, it's actually on the disk. So before it can be executed, it has to be mapped into the memory. So the PE file structure tells the Windows operating system about how to map that file on disk into the memory and how to locate all the different resources or all the different DLLs that the portable executable file needs. It's a data structure that tells Windows OS loader which information is required in order to manage the wrapped executable code. It includes dynamic library references for linking, API exports and import tables. That's a very critical information, and we'll be looking at actual examples in this particular video or in the next videos going forward. The PE data structure includes things like DOS header, DOS stub, PE file headers, optional headers, bunch of sections, and so on. Let's quickly look at an example. So this is a very simplified representation of a PE file's structure. This is how different sections of the PE file would look like, but this is a very simplified version. So it starts with a DOS header. then it has PE signature or PE header, then it has the COF header or the common object file format header. So COF is nothing but a common file format that was designed for executable files on any platform. So PE file is nothing but a file format built for Windows, executable file format built for Windows environment on top of COF header. Similarly, we have ELF file format for Linux environment. We have Mac-O file format for Mac operating systems. So after the COF header, we have the optional header, then we have the sections and how those sections are mapped into the memory. So if you look at the PE file from a very high level, it would primarily have two parts. One is the headers and the other one is the section. So the header would basically consist of things like DOS header, PE header, optional header, and the section table. So let us look at a very simple example. We'll be using a tool called CFF Explorer or COF. Let us look at a very simple example. We'll be using a tool called CFF Explorer or Common File Format Explorer. This is a very simple tool to parse COF file formats. If you have followed the previous videos, then this would come pre-installed with your Flare VM setup. If not, you can just search for it on Google and download this particular tool. It's very so let's load an executable. You can basically load any executable into CFF Explorer, any executable that is available on your Windows machine. Our whole purpose is to just look at the different sections of the file, look at the hex version of an PE file, and how we can quickly identify by looking at hex bytes that, okay, this is a portable executable file. So let's expand it. So once the PE file gets loaded in CFF Explorer, this is how it will look like. On the left hand side, you'll see all the parsed headers and sections that the tool could identify. Then there would be a bunch of other options as well. Let's look at the hex editor. So this is how a PE file looks like in a hex editor. So if you see, it starts with MZ as the magic bytes. So this is the first and foremost way to identify whether the file is a PE file or not. So if we go back to our presentation, we mentioned that the header of a PE file would begin with the DOS header, and this is the DOS header that we are talking about. So MZ is nothing but the magic number of a PE file. Then it consists of the DOS stub, which is called "this program cannot run in DOS mode." This is more like a legacy thing. If the PE file gets executed in a non-DOS environment, this is the error that would come up. It's not something which is used these days, but it's really difficult to remove it without breaking a bunch of softwares. So it's more like a legacy thing. It's not really useful. If you move down further, you will see that there is a section called PE. So portable executable files header begins after the DOS stub ends. So the magic number of portable executable file is PE0000. So if you look at the hex representation, it's 50450000. So that's our PE header, the one that we have highlighted over here. So this is how we can easily identify that this is a portable executable file that can run inside a Windows environment. So if you keep moving down, you will have things like the optional headers, which would contain a lot of other details about the PE file, and we'll look at the optional header in much more detail in the next video, because it requires a lot more detailed parsing and separate tools to really look at what these random values actually translate into. Text, data, resource, this is basically the section piece, this particular part of the PE file. So that's where the section part starts. This would contain all the code related information, all the API related information about the PE file. So this was just a quick demonstration to get you started about analyzing PE file, understanding how we can recognize a PE file by looking at its magic bytes and things like that. Thanks a lot for watching the video. Hello everyone to another video of expert malware analysis and reverse engineering course. In this video we will dive further into some of the more detailed sections of a PE file. So if you recall from our previous video, we looked at this high-level simplified diagram of a PE file, how the headers and sections look like. So in the headers, if you see, we have 4 different parts: the DOS header, the PE header, the optional header, and the sections table. So in this particular video we are going to look closer into the optional header and the sectional header. We have already understood pretty much how the DOS and the PE headers look like. To understand it, I want to use a very interesting diagram that is present on Wikipedia. Here is the link to the diagram. I have also provided that link in the description section of this video. If you look at this diagram on the browser, it is probably one of the best diagrams that you can find about portable executable files. So let me expand it a little bit. So if you look at this diagram, it pretty much starts with the DOS header with the standard signature of a exe file, which is 5A4D, and then you have the DOS stub, which consists of this program cannot run in the DOS mode, pretty much the standard stuff which we covered in the previous video. Then we have the signature of the PE file, which is 50450000. Then we have the machine information, number of sections and stuff like that. So this was something which we had already covered in the previous section. Now going forward, we want to spend some time on the other sections of the file format as well. So if you see here, the yellow part, this is basically the standard COF fields. So again, if you remember our discussion from the previous video, we mentioned that all the executable file formats are built on top of the COF file format, which is the compound object file formats. So this is what this diagram actually proves. You have the COF format, and on top of it, you have the PE file format bundled on it to create an executable for the Windows environment. So this is how standard file format is used to create proprietary file formats for different kinds of operating systems. So if you look at the standard COF fields, you have the magic, which basically tells whether it's a 32-bit or a 64-bit executable operating system. Then you have the size of the code section. Then you have the size of initialized data, the amount of size that an initialized executable will use, and uninitialized data size. Then you have the address of entry point. So address of entry point is the address where the Windows loader will begin execution. This is basically a virtual address which tells the Windows loader that this is the location from where the this particular executable has to be run. Consider it as an entry point. So whenever you will load an executable in a debugger, this is the location where the debugger will basically come and halt to. So it might sound a little bit crazy right now, but yeah, as we move forward with our PE file analysis, all these sections will make a lot of sense. Then we have base of code and base of data, image base, section alignments, and a lot of other fields like the operating system version. So this basically tells which operating systems are supported for this PE file. We have the image version as well. Then we have subsystem versions. So if you see here, all these fields are very specific to the Windows environment. So these sections can be specifically populated if you want to restrict the exe to run on certain versions of Windows and things like that. So if you come down to the data directories, you have some interesting fields again. The export table is basically a table, it's a table of exported functions. Then you have import table, which is a table of import functions, the resources that are used by the exe, and then you have the exceptions table. So if you want to have certain exceptions which are very particular to the executable, they can be defined in this particular area. Then you have certificate related information. So whenever you sign a binary, you can basically extract the certificate related information from this particular section of the PE file. You have debug related information, architecture data, config data. Then you have import address table. So import address table is something which stores the runtime address of imported functions. So if you want to use any Windows specific function, then its address has to be defined in the IAT, the import address table. We'll be working on import address table in quite a detail as we move into the other sections of malware analysis of PE files. So that's about the data directories, and in the end you have the section table. So the section table contains information related to the various sections available in the image of an executable file. The sections in the image are sorted by their relative virtual addresses rather than alphabetically. So here you can get information about the virtual size, the virtual address, and other important details of the section of the PE file. So there are a lot of different fields inside the header of a PE file or inside a PE structure. So you basically have to spend time on each of them to really understand what they mean. So coming back to our PPT, let's now jump to a demo. So if you remember our previous example, we used CFF Explorer to basically look at the hex representation of a PE file, where we looked at the different sections of the MZ header, the DOS stub, and the PE signatures. So let us look at other information which CFF Explorer provides us. So if you start looking here, you have information like the DOS header, that is something which we looked at. Then we have the NT header, file header, and then the optional header. So in the optional header, you will see all those sections which we just saw in the previous diagram on Wikipedia. So if you see here, you have the magic bytes, the major linker version, the minor version, size of code, address of entry point, base of code, image section. So all these sections are the same which we looked at in the previous image. So if you see here, what CFF Explorer did was it basically parsed all those sections of the PE file and extracted the offset values and added it over here. So this is how these security tools understand the nature of a PE file or the properties of a PE file. So that was my whole motive, to help you understand the PE structure so that you can really make more sense of all these values that have been added here. So you have the data directories. So if I bring you back to this example, the data directories is this particular part. So those are the values that you will see here, the relative virtual address. You have the export directory, import directory addresses. So everything that is RVA is basically a relative virtual address. We'll see in more details in our next video what exactly RVA means. So you have then the section headers. So if you come to the section headers, here you'll see all the other sections of the PE file which contains the other data which is important for the PE file. So what happens is, in the PE file you have the structure, and after the structure you have a bunch of sections which contain other relevant properties of the PE file. For example, the text section is normally the first section and contains the executable code for the application. So all the executable properties of the exe file are present in the text section. The data section contains an initialized data of an application, such as strings and stuff like that. So whatever value you are initializing in the PE file is stored in the data section. The RData section is basically a section. It's basically a name that is used for import tables that are located in the PE file. And at the end you have the RSRC, or
the resource section, which is a common name for the resource container section, which contains things like images or other such additional properties that you are using inside the PE file. So we want to look at another example of 010 editor, which is very much similar to this particular example. So if you load a PE file in 010 editor, it's a pretty neat hex editor, and it has a bunch of templates to parse different file formats. So it has executable file format templates as well. So if you load if you load an executable file and if you run the template, it basically analyzes all these sections and populates all the section values over here. Very similar to how CFF Explorer does it. It's just that I wanted to show you another tool, so this is one example that you can really refer at. So if you see here, it has the MZ signature, then it has the size, then if you keep moving down, you have the DOS header over here, then if you keep moving down, you have these NT headers. So this particular section, so this is where our optional header lies. So if you expand it, you'll see that you have the optional header. So if you expand the optional header, you'll start seeing all those same values which we just looked at in CFF Explorer and the Wikipedia's diagram. So you have the major linker version, minor linker version, size of code, base of code, and things like that. So if you understand how PE file format looks like, you can pretty much make sense of all this data. So this was all about the PE files structure. There will be just one more video on PE files, and that will be our last video, and that will basically give you a good idea of what happens when you execute a file in a Windows environment. Thanks for watching. Hello everyone, welcome to the last video about the PE files. So in the first two videos we spent time on understanding the structure of PE files, looking at its different sections and really understanding how exactly a PE file looks like, what is it consisting of, and how to make sense of different sections or different attributes which are present inside the headers of a PE file. So I just wanted to quickly go through another video to help you understand what happens when you execute a program inside an operating system. Let us for simplicity consider Windows operating system. So what happens when a program is executed? So when you run the binary, the shell picks up the information and it tells the PE file loader to run the file. So for every different file format, operating systems have different file loaders. So because in this case we are talking about PE files, so the shell informs the PE loader to run the file. The kernel then allocates virtual memory from the pool to fit the binary's image inside it. So if you remember when we were talking about import address tables and other virtual address spaces in our previous video, we used the term relative virtual address or virtual address. So I'll quickly help you understand what exactly virtual address means. So there are two types of memories on your operating system. One is the hard disk, which is your local storage, and the other one is your RAM or the random access memory, which is the volatile dynamic memory. So when a PE is sitting on the disk, it's basically saved on the local hard disk. When you run it, the operating system allocates a virtual address space in which the program can run. So this is basically an optimization that the operating system implements in order to make sure that the operating system allocates enough memory for an executable to really run. If let's say you are running a program, you do not want to continuously add more and more space to it. You just want to allocate it a wide space so that it can stay over there, run as long as it is alive. And once you close that operating system, once you close that executable, the operating system just flushes that memory out and the file still exists on the disk.
So this is how the memory management happens inside the operating system. So when it is sitting on the disk, when the file is sitting on the disk, it's basically having a local address space, and when it is executed, it has a virtual memory space in the random access memory. So what the kernel does is that it basically allocates the virtual memory for the executable to load. It then loads it over there in that particular memory section. Then what happens is the loader starts parsing the different sections of the PE file to start making sense out of it. I'm referring to the same sections which we talked about in the previous videos. If you remember, we talked about the import address table. So what the import address table contains is the information about all the import functions that the executable wants to use. So you might be familiar with DLLs in Windows operating system, which is the dynamic link libraries. So DLLs are nothing but executable codes and functions which can be reused by any program running on the Windows operating system. So DLLs are the classic examples of code reuse. You basically create all these dynamic link libraries and you let any other executable use them on demand. For example, if let's say you want to load a video inside your application, then you do not have to write the entire program to, create that movie file, create that media player where it should be loaded and stuff like that. All you can do is you can simply import the Windows DLLs which are responsible for running a video file on the operating system. You can just import them inside your code and you can use them to quickly launch any video inside your PE file. You do not have to write that same code again and again. Another example can be, let's say if you want to establish a network connection, you just don't have to write the entire code. You can use the Windows DLL libraries which are responsible for setting up the socket connections, establishing the connection, doing the handshakes and stuff like that, and the operating system basically takes care of all those things. So that's the major advantage of using DLLs. So every executable that is there on the Windows machine, they will be using some of the other forms of DLLs because they all rely on certain properties of the operating system to run, to execute, and do whatever behavior they want to do on the OS. So the information of all those DLLs is basically contained in the import address table. So as we move ahead with our other videos, import address tables will play a key role in understanding the behavior of an operating system. What kind of properties does that executable contain? Because we all know what DLLs can be used to perform what kind of tasks. So we can immediately guess that, okay, this particular executable wants to connect to internet. This particular executable wants to launch the shell prompt and perform certain commands inside it. This particular executable is trying to launch PowerShell and stuff like that. So it becomes slightly easy to really understand what are the actual behaviors of the executable file. So moving to the second part, what happens is that the PE loader, once it has populated the import address table with the addresses of all the DLLs which are there in the memory, it will start recursively parsing through all those symbol functions, locating them in the memory and assigning it to the executable. It's the standard process about how an operating system loads a process into the memory. The kernel then pushes the current location into an execution stack. So for example, what happens is when you are executing a certain section of the code and all of a sudden you call a DLL which says that, okay, play the movie. So the command has to now jump from your section to another memory section where the DLL is loaded. So what the kernel does is that it stores the current execution location on the stack, jumps onto the DLL memory location, execute that DLL, then come back to the same place where it had last executed your binary and then start the step instructions again. So this is how kernel does a memory mapping of your executable with other linked libraries that you are using from the Windows operating system. So the kernel basically pushes the current location into an execution stack so that it knows where to come back to. It then jumps from the current memory to the shared memory location where the DLL is loaded, executes it, performs the action, then pops the memory from the stack and returns back to begin the further execution of your program. So once the execution is complete, the kernel just uh, deletes all the virtual space that it had created for the executable. And this is how a program basically gets executed inside the operating system. A very high level overview of how a program would run inside an operating system. I would highly encourage that you can go ahead and read more about a lot of interesting operating system concepts like segmentation and paging and a lot of other stuff related to dynamic linking libraries, how operating system manages memory and stuff like that. Those are really, really interesting computer science concepts. So at last here, this is a very simple representation of what we just talked about. So if you look at the first point, it says that running program gets its own area in RAM, which is our virtual memory, to hold the code and the data. So everything that was there inside the executable gets written onto the RAM, and then the CPU basically executes all those instructions one by one, doing all these memory managements, linking with the shared libraries, executing them, coming back, and stuff like that. So that's how a program gets executed in the memory. So this was all about understanding the basic behavior of PE files, its structures, and how an operating system looks at a PE file. So going forward, we'll start looking into specific cases of static malware analysis, and then we'll look at different cases about how we can analyze a PE file to understand whether it has certain suspicious or malicious properties inside it or not. So that's all about this video. Thanks a lot for watching.
Hey everyone, in this video we want to talk about the compilation process before we can jump into the actual reverse engineering. So if you remember our previous videos, we talked about how an operating system loads an executable into the machine, how exactly it runs, how the linker objects basically run that executable, how the operating system manages memories and stuff like that. So in this video, we basically want to uh, move a step back and talk about how we create the executables which you run on the operating systems. Now, when you are trying to build up a software, you would obviously be choosing one or the other programming language in which you can write your high-level codes. Now, those high-level codes have to be converted into the machine understandable code so that different computers or different architectures can basically run that operating systems. So the reason why softwares gained so much popularity is because when you create a software, it can run on any device on whatever operating system that it supports. It's not just dependent on one machine or one single device. It can run on all the similar operating systems that your software can support. So that's the reason why there was an exponential growth in the software development field. So this was only possible because those softwares can be converted into some machine understandable codes that can universally run everywhere. So if we talk about compiler-based high-level languages like C++, then when you're writing your software, you will basically be creating your program in the language. You'll start defining your functions. You'll start defining what kind of operations can happen when your function is executed and things like that. So once you have completed writing the code, you basically run it through a compiler. Now, the compiler follows 4 stages before it creates the final executable. So the 4 stages are, the first one is called the pre-processing stage. So as the name suggests, it's a pre-processing stage, the steps that happen before processing. So what exactly it does is that it removes all the extra comments that you might have added in your code. It expands all the macros that you might have added. If you have things like regexes and all, then all those things gets expanded. It also starts expanding the included files. For example, if you're importing different C libraries into your program, then all those things will start getting expanded in the pre-processing stage. From there, the control flows to the compiling stage. So in the compiling stage, the result of the preprocessor is used to generate the assembly language. So assembly language is a low-level programming language which kind of gives you some understanding of how the execution will look like at the processor level, along with giving you the ability to write those instructions. So it's not completely machine code, but it's also not completely like a high-level programming language like C or Java. It's somewhere in between. That's why it's called a low-level programming language. It's pretty old, and it's based on the initial days when the computer architecture was still being developed. So assembly language, or having the idea of interpreting assembly language, is going to be a key skill when we would be reverse engineering the malwares. From compiling stage, the processing then moves to the assembly stage. So the assembler will convert the assembly code into pure binary codes or the machine code, the zeros and ones. So as you know, computers can only understand the binary values, the zeros and ones. They cannot understand the high-level programming languages that we write. It's just the abstraction layer which makes it easy for us to write our code in a high-level understandable language like C or Python or Java. But ultimately, what computers really need is the binary level information. So that's where the assembly stage comes into picture. It generates the final machine code that the computers can understand and execute. So after assembly, it moves to the final stage, which is the linking stage. So what the linker does is that it combines all the information gathered from the previous three phases. And for example, when you write a software, it's not just one single program that you write. You basically write a bunch of different programs, and you are using the features of all those different programs. So what linker does is that it starts combining all those together into a single module and finally generates your exe file or the executable file. So enough of text. Let's look at a pictorial representation as well. It's pretty much what we just talked about, but in a much shorter and nicer way. So consider the example where you have your source code written in C. So the source code file will have an instruction of .c. It goes through the preprocessor phase, which is the pre-processing phase. It means it removes all the comments, expands the headers and everything. From there, the control comes to the compiler. The compiler generates the assembly code. That's where I'm stressing a little bit, because we are going to deal with a lot of assembly code in future. Now this generated assembly code then flows through the assembler, which creates the object file or the final binary instruction which the computer can understand. Now using all those information, linker then finally creates your executable file or the exe file, which you can then distribute across, and it can run on any Windows operating system. So that's all for this video. Thanks for watching. So continuing from our previous video, we'll cover a quick demo about how we can compile a source code to generate an executable. So here we'll be taking an example of a C based source code, and then we'll be going through the same step which we talked about. Like, it will first go through a compiler, it will generate the object file. From there, it would go to a linker, which will include all the header files, and from there, it will finally generate the executable or the exe file. Once the exe file is generated, we can obviously run it, And if you remember, the beginning few videos of this module talked about how actually an operating system loads an executable into the memory. So in this way, we'll be able to connect that entire process together about how we start writing the code, how we compile it, how we generate the final executable, and what happens when the operating system runs that executable. So once this entire loop is clear, that's when we'll start jumping on to the actual reverse engineering problem. So if you remember in the previous video, we mentioned about assembly code being getting generated out of the compiler. So if you look at the usual engineering process, it follows from source code to the compilation of code to the generation of executable file. Now, when you talk about reverse engineering, you basically go in the other direction. When you're looking at a malware sample, you're actually looking at an executable file. You don't have the object file or you don't have the source code file. So what do? We use tools like decompilers. So just notice the term decompiler. It's actually the reverse of compilation process. So it picks up an executable file and it converts it into a low-level understandable format like assembly so that you can understand what operations would that executable do. So this was the reason why I went through this entire cycle because, if you look at an exe straight away, you also have to understand where that exe came from, what was the process behind it, and why spend so much time in understanding those things when, you can just look at the behavior and say that, okay, these are the things that the malware is doing. The whole challenge is that an exe is basically a final um, compiled file. So you cannot look at the exact source code from which it was generated. You can do it in certain cases where defined decompilers are available, for example, .NET, but not with other file formats or not with other programming languages in which the exe was compiled and generated with. So that's the whole reason of creating all these initial few videos to really help you understand the meaning of reverse engineering. Why exactly is this term called reverse engineering? That is because we are not working on just the code itself. We also work on the final outputs and we pick it up and we start tracing it back. We start tracing it back to its origins to see what exactly was the purpose of creating this file. That's the whole idea about the reverse engineering piece of malware analysis. So let's move to a demo. Here I'm using an example file called hello.c. So I'll also include this example file in the course resource section so you can download it and you can um, test these on your own as well. Now I will be using the standard GCC compiler, which is used for compiling C++ programs. You can easily download it from the internet. I can provide you the link in the resource section as well. So once you have downloaded the compiler, you have to make sure that the path is defined as well. So once you have defined the path, GCC would be recognized as a command line operation. So we can give the command gcc-s followed by hello.c. So -s tells me to generate the assembly code of the file. So if you see here, a new file called hello.s has been created. So let's look at the content of hello.s now. So that's how the file would look like. If you see here, it tells me that the original compiled file was hello.c, the main function. Then if you start looking here, there are a bunch of assembly instructions. So we'll be going through in much more details as to what those assembly instructions actually mean. but this was just a demonstration to show you how we can generate the assembly if we have the source code. So we can just compile that code to generate the assembly file. So now if you want to generate the final executable by using your source code file, all you have to do is use GCC followed by O and then give a name to the executable, let's say hello itself, and then the name of your source code file, which is hello.c. Now when you run it, GCC will compile it and generate an exe file for you. So this is our exe file. Now when you run the exe file, you get the output as hello world. So that's what the program was designed to do. So if you look at the program, you'll see that it's a pretty straightforward standard program which includes stdio, then defines a main function, and then uses printf to print hello world onto your screen and then return 0. So that's how we converted a source code into an executable. Now, when you are doing the malware analysis, it will be the other way around. It's easy to understand how exactly or what actions a source code is doing, but you cannot really look at an exe file and say that without even running it, you cannot say that what actions it is doing. So if you look at the content of a C file, you won't see much inside it, like it's all random. And it will basically point you to the files parsing information, things that we had looked out in the previous videos. So this was a quick demonstration to help you really understand about the process of compilation. Now we have covered a lot of ground on how exactly programs are created and how exactly they are compiled and how operating systems load them into the memory. We have this background built up so we can start focusing on the reverse engineering process where we'll start decompiling executable files to understand what operations they are doing on the system. Thanks for watching this video. Hi everyone. In this video, we will look at some of the static analysis tools, primarily for PE files. So what I mean by static analysis is that you are not going to run or execute that file. We are only going to use the standalone on disk version of the file, and we'll run it through a bunch of static analysis tools to understand its behavior. So if you remember in our previous videos, we used tools like hex editors and file format parsers to understand the structure of the file. In this video, we specifically want to focus on some additional tools which can help us understand whether the file that we are looking at is actually a malware file or not. So these are pretty popular static analysis tools, and they are freely available for us to download and use. These are the list of tools that I want you to quickly go through. Let us come to our virtual machine. So all the tools which I'm going to discuss is a part of the Flare VM utility as well. So if you have installed Flare, then you will have these tools already present on your machine. If you haven't, you can individually search for them and download them, and that should also be sufficient for you to work with the tool. So the first tool that I want to talk about is hashcalc. It's a pretty simple and standard tool for calculating hash of a file. So if you drop any file inside it, it will help you calculate MD5, SHA-1, SHA-2s, or whatever values you want. So this is a very useful tool for calculating files hash, and you can use this as, an IOC, or you can use it for searching on VirusTotal and other such services. The second tool that we want to talk about is EXEinfo. This is a very interesting tool. So what EXEinfo tells us is it gives us certain informations about the file, like the entry point, the EP sections, the file's offset, file size, overlay sections information, And the most important part is it also helps us understand if the file is packed or not. So here I'm using two different malware files for this video section. I'll be uploading both these malware files and I'll provide the link in the description of this video so you can go ahead and download it from there so that you can replicate the same analysis. So the two files that I'm using is first one is Maze ransomware. So Maze is a ransomware family that has been out there for a while. This is one file, and the other one is another backdoor, which is backed by a known packer called UPX. So in exe info, let us first drop our Maze ransomware binary. So here you'll see that it will tell us the entry point. If you remember, entry point is something which we saw in our previous video. That's the um, location from where the main PE loader of the operating system will begin executing the file. And you have the EP section, the initial few bytes of the file, offset, linker information, file size, and overlay information. Now, if you see here, it tells us that it's an exe file and it has a standard compiler section, nothing out of ordinary. So that's it. It did not really pick up anything really different, or it did not really pick up any packer information in the file. Now let us try our UPX bagged file. If we drop it over here, you'll see that it tells me that the EP section consists of a UPX header. Its file size is this, that's the overlay information, and then it tells me that it has been packed by this particular version of a UPX packer. So if you don't know about UPX, it's a pretty well-known packer for packing the portable executable files. So what happens by packing is that you actually change the overall structure of the file and you replace it with your own structure. The file still works as a standard executable. For example, if your program is designed to launch calculator, if you pack it with UPX, it is still going to launch calculator. The only difference is that a UPX packed file will not have those standard sections which we saw in our previous three videos. They will basically be replaced by UPX's own packer. So when you run it, the file unpacks, and that's when the proper section gets created. So that's the whole advantage of packers. So packers help you hide all these information like the header information, which import tables have been used, and things like that. So that's why malware authors rely on packers in order to hide some of these behaviors from these static analysis tools. So it also tells me that the packer can be unpacked by downloading the uh, unpacker from the official website, and you can just run the unpack command and it will give you the unpacked or the actual binary, the actual malware payload that you can analyze. So this is the importance of exe info. It just helps us analyze that, okay, there is no packer inside the file. The next one is PEID. That's another interesting tool. Let's launch PEID, drop our packed file. So if you see here, again, very similar to our previous tool, it tells me the packer's information. So this is another common tool which malware researchers or security analysts use to identify if a file contains any packer or not. So what happens is these tools rely on a standard set of list of known packers. If the malware is packed by a custom algorithm, then these tools would not be able to identify those packers. If it is packed by a known commercial packer, which we have seen being utilized by malwares in the past, in that case, these tools will be able to identify the packer information. PE Bear is the next tool that we want to look at. Let's run it and drop our Maze ransomware file over here. So if you see here, it's pretty much containing the same information which we have went through in our previous 3 videos. It tells us a general information about the file like its hash, size, the DOS header, the rich header information, file header, optional headers, section headers, and the import table. So let's try our other file that that would give us some interesting results here. So let's let's look at our UPX packed file. So if you look at the DOS header and if you start scrolling down, that's where you will see the UPX header inside it. So this is how these tools identify that the file is actually packed by a packer. So instead of having the standard sections, it has UPX sections inside the files. This means that the file is actually packed. So it also has the disassembled information. This is something that we'll be looking at later on. This will be utilized when we would be reversing the files using disassemblers. So PEBear was another tool that is pretty interesting for us to know about. Okay, so in this video, we will look at 2 more interesting tools. One is PPEE and the other one is PE Studio. So the new thing which we learned in our previous couple of tools is the way of extracting general information about the file, like its hash value, and how to identify whether the file is packed or not. So whenever you're doing static analysis of any PE file, the first thing you want to know is that is it packed or not? If it is not packed, it makes things easy for us. We can start using our standard analysis techniques. But if it is packed, we have to make sure that we first unpack that file so that we have the actual file header information. Then only these tools will be able to give us a better information about the file's properties. So let's look at PPEE. So again, if you have Flare installed, this tool will already be available on your machine under Utilities directory. In fact, all the tools that we have looked at in the previous video and this video would be present inside the Utilities folder. So let's execute it. Now let's drop our file. Let's try our ransomware file first. Now, if you look at PPE's UI, you'll see that the starting information is exactly same as what we have looked at in some of our other tools and videos. It has information about the headers, file sections, and stuff like that. So this is this is the reason why I first went through uh, helping you understand how to read a file format so that you're not surprised by all these random information that you see when you start using these tools. So if you have a basic idea about file formats, it will be pretty easy for you to really understand what information these tools are trying to extract. Now, the interesting part about PPEE is the strings that it extracts from the file. So strings is a standard Unix command. You can run it against any file. You can just type strings followed by the file, and it will tell you all the strings that it could recognize inside the file. So if you see here, these are the strings that the tool was able to identify in ASCII format, and there are a bunch of strings that the tool could identify in Unicode format. There are 2 separate sections for them. So here you can see some of the strings are pretty readable, like the DLL imports, user32.dll, gunner32.dll, but a lot of them are just random strings. They do not really make any sense. Just because those characters are readable and exists in a defined order, that's why the tool picked them up. If you come to Unicode, you'll see bunch of Unicode information. So you have linker files, temporary files, cryptographic library is being used, then you see that it's basically trying to run an SQL command, select star from Win32 shadow copy. So if you want to know more about shadow copies, it would be really interesting. And if you have looked at ransomware files before, this much information is enough for you to understand that the file that you're looking at is highly likely a ransomware file. If it's still not very clear to you, we'll probably be looking at another interesting aspect called suspicious. So what PPEE does is that it runs its own heuristics to extract a bunch of suspicious um, strings for you. So if you look at the strings over here, you'll see that it has extracted content type. This is basically an information that is used when you are trying to connect through an HTTP server. It's also looking for antivirus products. It is also pinging bunch of servers, deleting ping command, security centers, shadow copy information, and things like that. So let's go back to our Unicode strings. So if you keep scrolling down, you'll see information like it's looking for local settings, Internet Explorer information, local data information. Then as you come down, you'll see a string called encrypting whole system. Then another string called encrypting specified folder in the path parameter, and then finished. These strings are enough for us to identify that this executable is highly likely a ransomware. Now, so I forgot to give a short explanation of ransomwares. So ransomware is a family of malware which takes hostage of your machine either by completely locking it or by encrypting every file on your machine. It then demands for ransom money in the form of cryptocurrencies, most commonly by using Bitcoin. So once you make that payment, then only the malware authors would allow you to access your machine or basically decrypt all the encrypted files back into readable format. It's a pretty well-known malware family that has been a huge problem for the security industry in over the last 5 and 6 years. So if you come down over here, you will see that there is a ransom note. So these strings are really common in ransom notes. You'll see that it says that your file has been encrypted by RSA 2048 and Chacha algorithm. The only way to restore them is to buy the decryptor. And to buy the decryptor, you have to pay a certain amount of bitcoins or cryptocurrencies that the uh, ransomware authors are demanding from you. They're also kind enough to share a Wikipedia link for you to read more about the file. So what that basically means is that they are trying to tell you that no matter what you do, you're only going to get your files back unless and until you do not pay for getting the decryptor keys. So this is a very short introduction. You can read more about ransomware. There is tons and tons of information available. The whole purpose here is to help you understand uh, how we can use static analysis tools to really identify different types of traits and different types of behaviors inside the file. And once you start looking at all these malwares more and more, that's where you start understanding how exactly to understand the behaviors of the file. In fact, if you see here, there is a string called C maze ransomware. So maze ransomware family basically. So that's the file which we are currently looking at. That's the ransomware family that this particular file belongs to. So URL is another specific section that the tool creates. So if by running the string command, if the tool is able to extract some URLs, they will basically be presented over here. Right now, it could only extract http://s. It means it's substituting a value that is defined in a different variable. So that's how they are putting up the value over here and calling out to this particular domain. If there was an actual domain over here, it's possible that it might be the command and control server of the ransomware. So that was about PPEE and how we can understand the malware's family and behavior by using the static analysis tool. The last one that I want to talk about is PE Studio. That is also one of my favorite tools because it gives us a lot more information about the file. So let's again drop our ransomware file over here. This is how it looks like. So if you see, PE Studio is still running a bunch of heuristics on top of the file. So the good thing about PPE and PE Studio is that they have their own heuristics, their own ways of determining whether the file that you're looking at is suspicious or not. So if you see here, PE Studio has figured out that the file you just scanned has a detection ratio of 63 on VirusTotal. So VirusTotal is a web service where you can scan a file or you can search for a file hash and it will tell you how many of the well-known antiviruses have a detection for that file. This is a very good way of identifying whether the file is bad or not. If all the major antivirus vendors are saying that, oh, this file is known malicious, then we know by certain that, okay, this is a malware file. So if you look at some of the detection names, it has ransomware and the ransomware's family inside it. So this is also one indication of figuring out that, okay, the file that we are looking at is nothing but a ransomware file. Other than that, there is an indicator section. This is something really interesting that PE Studio provides us. These are a bunch of indicators that PE Studio has extracted for us. So if you see, it has strings which are marked as blacklisted strings. It also references a lot of blacklisted libraries. So this is the string section and this is the libraries section. So if you go into these sections, you can see which ones are blacklisted. The file is also known as bad on VirusTotal. It is also importing symbols which have been tagged as bad, and the file references MITRE's techniques. So these are a bunch of indicators which PE Studio used to give us a verdict that the file that we are looking at is actually bad. Let us look at the library. So if you come here, you'll see that these top ones which are marked as red are the blacklisted libraries that this particular executable is using. So security service support provider interface, secure32.dll, net API, it's basically a Win32 API, DLL for raising net connections, then crypto API. This is the one which gives us the biggest indication about the presence of a ransomware on the machine because this is the library that would help you encrypt the file. In the imports table, to give you a little bit of context about these two, you can even follow the link. You can right click on it and you can go to search MSDN. So search MSDN basically opens up your browser and it goes to Microsoft's MSDN library and it searches for this API to give you more information about why this is used. So this is a very good way of understanding the library's information. So MSDN is your best tool when you want to understand what particular Windows library is used for which specific purpose. Now let's come to the strings section. So in the string section, you'll see information like post, program cannot run in DOS mode. Then there are a bunch of get and post information. So these are the strings which we also saw in when we were looking at PPE. So decrypt file.txt, this is basically the ransom note file which gets created on your machine, which has all that ransom note information that your file has been decrypted. You have to buy your file has been encrypted. You have to buy the decrypted tool to get back your files. So This is where PE Studio is really useful in understanding the behavior of files. Let us also try our UPX packed file in PE Studio and see what we get as result. So in UPX packed as well, you'll see similar sections. VirusTotal tells us all the known antiviruses which have a detection for this file. Then it is still calculating for other indicators inside the file. You have the file headers. This is something which we have already seen a couple of times in the previous videos. You come to sections. It tells me that that's the entry point. It also has figured out that the file has UPX packer inside it. It tells us what percentage of the file is packed, the file percentage ratio, the entry point information, and a bunch of other blacklisted details that it could figure out from the file. So PE Studio is also a very handy tool in understanding more traits and behaviors of the file.